Okay, I hope I'm live. So just let me know in the chat section if I'm audible. If I'm audible, then it's perfect. If I can quickly get some confirmations before starting with the webinar and before setting the agenda of the webinar, then it would be really great. So we have 47 people which are watching this webinar right now. So it would be really great if I can get a small confirmation. So Deepak, so just to clarify, Deepak was to deliver this webinar, but he got some urgent work to do. So because of that, I would be taking this webinar. And before starting with the webinar, like thank you, Rahul, thank you, Rahul Dev, thank you, people, thank you so much. Perfect. Perfect. So what we are going to do is we are first going to set the agenda for the webinar, and then we would be basically working on that. So let me quickly share my screen so that we can start with the webinar. Okay. So now basically we will basically solve 4 questions today, and we will be solving the question using the same method that we are using the past 2 webinars. Uh, the webinar would not be a monologue. It would be more of a dialogue. You would also be participating in the webinar. You would also be answering in the webinar. So I would solve one question and I'll give one question to you. And then I'll solve another question and then I'll give another question of the same type to you. And I will give you these 2 questions with the help of a contest. And the link to the contest is given in the description. So if I can quickly show you the link to the description. So let me quickly show you. So you can go to the description and you can see the link to the webinar, right? So I can quickly show you for your reference, right? Right. So if you go to the description, you can see the link over here. So this is the link that I'm talking about. Let me quickly encircle it. So this is the link that I'm talking about, right? I hope you click on this link, and as soon as you click on this link, you would be able to get to the contest. We would be using this contest to drive engagement and basically to have a dialogue on this webinar. It won't be a monologue, the way basically the way where only I am teaching and you are not doing anything. So as usual, as we had this past 2 contests, so we will be using this thing. We will be using this contest to drive that engagement. Okay, perfect. So let me open this test in a normal window. Yeah, perfect. Okay, so over here, if I go to this contest, if I start this contest, right? So then we would be able to see that there are 2 questions over here. First question is minimum steps to 1, and other is palindromic substrings. Okay. So what we are going to do over here is, first I'll take a simple question, and with the help of that simple question, I'll set the context. I'll tell you what exactly dynamic programming is, how do we solve dynamic programming question. So I'll set the tempo for the webinar with the first easy question. And after that, what we will do is, after solving this easy question, what we will do is then we'll solve a harder question, harder version. So you can say this would involve 1D array, right? In dynamic programming, what happens is dynamic programming is just recursive question plus a storage array. So in the easy question, we would be using recursion plus a storage array of 1 dimension. So we would be using 1-dimensional array. And the second question would use a 2-dimensional array. So it would be of larger, you can say it would be of larger complexity. If you're comfortable with dynamic programming and if you're comfortable with the basics, I would recommend you can start with the contest. Start giving the first question, then move to the second question. I have no issues with that. Apart from that, another thing that I am going to tell you is what we are going to do over here is we are going to start from where we left off. So what we did was we had this webinar on dynamic programming, which we had on 11th June 2020. It was an elaborate webinar. It took around basically 2 or 15 minutes. So it was an elaborate webinar. And what I had done in this webinar is I had described you that the way to learn dynamic programming is through patterns, right? So like, for example, we had taken this pattern on Fibonacci, which was which used to take 1D DP, right? And similarly, this was pattern on 0-1 knapsack and the unbounded knapsack and all these questions. So what we are going to do is, last time we started with the pattern Fibonacci, and we basically took one problem from it, the house thief question we took from it, and then we went on to the pattern of 0-1 knapsack. This time we are going to take different pattern, right? So this time we are going to take one question from Fibonacci numbers because it's a basic pattern, but we are going to take a different question from house thief. We are going to take staircase. Basically the next question that the next pattern that we are going to do is, this time we are going to take strings. So we are going to take longest palindromic substring, and we are going to solve count of palindromic substrings, right? So I would ideally recommend to see this video in continuation to what you have in continuation to this webinar that we had basically taken on 11th of June, right? Okay, perfect. Now let's start with the webinar. Okay, so to begin with, what we're going to do is we're going to start with the first question, and let me describe you the first question. After we are done with the first question, what we are going to do is we have to come at a generic solution to solve a dynamic programming question, that these are the steps to solve a dynamic programming question. So let me take an example, and with the help of that, I will elaborate and I'll explain what exactly is dynamic programming and how do we solve it. Let me first give you a question, right? So let me first give you a question. So the question is that you are given with an integer n, which tells you that it's an n-step staircase. So let's suppose, for example, you are given with n equal to 4, right? So that would mean the staircase has 4 steps. So staircase has 4 steps, right? So what you have to do is you have to tell number of ways in which you can go from this step to the topmost point, right? Number of ways in which you can do that. In one step, in one thing, you can take either 1 step or 2 step or 3 steps. Let me explain this question again to you. So what is given to us is we are given with a staircase, and staircase has n number of steps. It has 4 steps. This is the first step, this is second step, this is third step, and this is fourth step, right? We are standing at the 0th spot. Now we have to tell number of ways in which I can go from this place to this place. Given that you have 3 ways, you have 3 options. Rather than writing ways, let's write 3 options. You have 3 options. You can either take 1 step, or you can take 2 steps, or you can take 3 steps. In total, you have to cover these 4 steps. So you have to tell number of ways in which you can go from the 0th spot to the topmost point, right? So the answer is pretty clear. You can say that I'll go 1 step, 1 step, 1 step, 1 step. So you can go 1, 1, 1, 1, or you can go 1 to 1, right? You can go 1 step first, and then you can take 2 steps, and then you can take another step. You will reach from here to here. Another way would be you can start with the second step first, then you can move 1, and then you can move 1. Or you can do it this way. You can start with 1 step, then 1 step, and then you can take another 2 steps, right? Then another way would be you can take 2 steps at the first, and then you can take 2 steps again. And the another way would be you can take 1 step and then you can take 3 steps, or you can take 3 steps first and then you can take 1 step, right? So these are the steps I think that I have. Apart from that, I don't think there is any other way to go from the bottommost point to the topmost point. I don't think there is any other way, right? So in total, we have 7 ways, right? We have 7 ways over here. There are 7 ways to go from this spot to this spot. Just a quick confirmation from your side. I hope you understood the question, right? I hope you have understood the question. Just let me know in the comment section. Just let me know in the chat section if you have understood the question or not. Let me take another example for you. You can give me a hands up, a thumbs up if you have understood this question, or you can try this test case as well. So let's suppose n is equal to 3. That means there are 3 steps which are given to us. So then what we are going to do is we are standing at the 0th spot, then we are standing at the first spot, and then basically we 2 and 3. We have to go from 0 to 3. So how many ways are there? So one way is 1, 1, 1. Then the next step would be 1, 2. Next would be 2, 1, and 1 would be 3. So there are 4 ways, right? Perfect, perfect, perfect. Thank you for the confirmations. And I see a lot of people, lot of regular viewers. Yeah, I saw people who have been watching the graphs webinar and similarly other webinars on arrays. Right. Right. To answer your question, Nandita, we cannot take 4th step because we have only 3 options. So these are the 3 options that we have, right? Either we can take 1 or we can 2 or we can take 3, right? So we cannot take a 4th step. We have only 3 options, right? Now let's try to solve this question. Let's try to solve this question where basically we have to find number of steps, number of ways in which we can reach to the topmost ladder. Okay, I hope I've answered you, Nandita. Perfect. So we have these 4 options. We have these 3 options. Now to solve this question, the first thing that you have to do is you have to just apply brute force approach. You have to solve this question by recursive approach, right? So apply your recursion. The dynamic programming is firmly based on the foundations of recursion. So try to solve this question through recursion. So what we will do is, if we have to solve this question through recursion, the principle of solving this question using recursion, principle of solving any question through recursion is that you have to assume that if you want to solve this problem, for example, you want to solve this problem for n equal to 4. So this is the main problem that you have. You have to assume that the answer for smaller sub problems will come. So you have to build the answer to this problem using sub problems, right? So let's try to find those sub problems. So for example, if somebody tells me that there are n steps, or let's suppose if somebody tells me there is n equal to 5 steps, right? So this is 1, this is 2, this is 3, this is 4, this is 5. And somebody tells me that you are standing at the 0th spot. Now tell me number of ways to go from 0 to 5, right? So what I'm going to do is I'm going to tell him that if the problem is n equal to 5, the problem is to go from 0 to 5, right? So what I'm going to tell him is let's try to solve this question in a different way. Let's not try to solve the whole question as it is in one go. What we can do is you tell me the answer of a small problem, smaller sub problem, and if I know the answer of that smaller sub problem, I would be able to solve this bigger problem. So what I'm going to say is that you want to find the number of ways to go from 0 to 5. So do one thing, take one step, right? If you take one step, you will reach to this place. Then can you tell me number of ways in which I can go from 1 to 5? Can you tell me the number of ways in which I can go from 1 to 5? So what I'm trying to tell you is that take the first step. If you take the first step, then the problem gets reduced to 1 to 5. So take another step, right? Take 2 steps, right? If you take 2 steps, the problem is reduced from 2 to 5. And if you take the 3 size step, then the problem gets reduced to 3 to 5, right? So if somebody can tell me number of ways in which I can go from 3rd step to 5th step, number of ways in which if somebody can tell me the number of ways in which I can go from 2nd step to the 5th step, and if somebody can tell me number of ways in which I can go from 1st step to 5th step, then let's suppose its answer is X, let's suppose its answer is Y, then let's suppose its answer is Z. Now let's suppose the answers for these smaller sub problems comes to us. So let's suppose the answer is X, Y, and Z, and let's suppose the answer to these comes to us. Now let's try to find the answer for 0 to 5. Okay, so what would be the answer for 3 to 5? Let's quickly try to find it. So what is 3 to 5? In fact, 3 to 5 is this only. I'm standing at 3. I have to go to 5. It's exactly similar to finding the number of ways to go from 0 to 2. Going from 3 to 5 is exactly same as going from 0 to 2. It doesn't matter from where you are going and from where you are starting and from where you are going. What matters is the difference of number of steps. In this question, the difference of number of steps would matter. So for example, over here, what we can do is, we can see that these two are exactly the same situations. So what I can see is that there are only two ways. One is I can take one step, or I can take these the two sized step directly. So there are two ways to go from 0 to 2, or there are two ways to go from 3 to 5, right? So what I can see over here is, the insight that I want to make from this is that there are two ways, 1, 1 and 3. To go from 3 to 5, there are two ways, right? I've already taken a third step to go from 0 to 3. I've already taken a 3 side step to go from 0 to 3. So in total, what I can say is, to go from 0 to 5, I can place 3 in front of them, and both of these ways would become a way to go from 0 to 5, right? If I know the number of ways to go from 3 to 5, I know that there are two ways. I can append 3 in front of all those two ways, and that will become my ways to go from 0 to 5. Similarly, whatever is the number of ways to go from 2 to 5, I can find, and what I can do is I can append 2 in front of them, and I can make all those ways to go from 0 to 5. Similarly, if I find the number of ways to go from 1 to 5, then I can append 1 in front of them, and I can make all of them as number of ways to go from 0 to 5, right? So over here, what I'm going to do is, now I'm going to basically see that that once I know the answer of this, once I know the answer of this, and once I know the answer of this, in front of it, I can append 1, in front of it, I can append 2, and in front of it, I can append 3. So these will become number of ways to go from 0 to 5. This will become number of ways to go from 0 to 5. And this will basically become number of ways to go from 0 to 5. So for 0 to 5, the answer would be answer of this plus answer of this plus answer of this, right? Let me quickly show you. Let me quickly show you with the help of an example. So let me quickly show you with the help of an example for which the answer we already know. So you know that for n equal to 4, the answer will be 7, right? We already know that. So what we are going to do is, for n equal to 4, let's see if the answer 7 comes or not. So what we are going to do is, we are going to make a call. We are going to take one step, and we are going to make call for n equal to 3, right? Because as we have already seen is that number of steps matter, right? Over here in this question, number of steps matter. What matters is, as user with the username Hardy has already written, that number of steps matter over here, right? So if earlier number of steps were 4, if I take one step, then the number of steps left are n equal to 3. Similarly, if I take 2 steps, number of steps which are left to me would be n equal to 2. And if I take the third step, number of steps which will be left for me would be 1. So I know the answer to this. The answer for n equal to 3 is, I can say that the answer for n equal to 3 would be, the answer is pretty simple, right? The answer is 4. We have already seen. For answer n equal to 2, we have already seen it would be 2. For answer n equal to 1, if there is a single step, then there would be only one way to cover that, which is 1. So as you can see, I already said that my answer would be sum of all these values, 4 plus 2 plus 1. So my answer would be 7, right? So my answer would be 7. So that's why what I can see over here is that I'm able to find the recursive solution, right? So let me quickly write the recursive solution for you. And then what we can do is, then we can try to figure out how to apply dynamic programming to it. First, let me try to solve it recursively. So let me quickly try to solve it recursively. So, okay. So let me quickly move to the dynamic programming package, and let me quickly write this thing over here. So let's name this class webinar questions, and let me quickly do this. Perfect. Now what we are going to do is, we are going to quickly take the input. So don't worry about the language that we are using over here. The concepts of dynamic programming and recursion are language independent. They remain same for whichever language that you choose. So they will remain same. So what I have to take input over here is, I have to take input of n equal to 1 for n, sorry. So I have to take input for n, right? Now let's try to solve that question. Okay, so let's name this question, let's name this function as staircase, and let's pass n to it. And now let me quickly write the method to it. So I would try to solve this question using the same insights that we have used just now. Okay. Okay. So the first thing that we have done is we have assumed that the answer for the smaller sub problem would come. So the smaller sub problem would be staircase of n minus 1. I assume that the answer would come and I've stored in X. Similarly, I assume that the answer for this part would come and I'm storing it in Y. And similarly, I'll assume that the answer for the last part will come and I will store it in Z, right? Then my answer would be X plus Y plus Z, right? Perfect. Easy peasy. So this was the question that I was talking about, right? This is the simple first draft question, or this is the simple code that I wanted to write in recursive, in recursion, and it assumes that the answer for the smaller sub problem would come, right? And what I wanted to do over here is, now I wanted to solve it completely. There is still one component left in this recursive question. What is that one component? It's the base case. Base case is left over here. Base case is not written over here. So let's quickly try to add the base case. So let's quickly try to see. So for adding base case, we have to solve this question for a smaller test case. So let's try to solve it for n equal to 4. Right? So if I try to solve it for n equal to 4, it will make a call to n equal to 3. For n equal to 3, it will make a call to n equal to 2. For n equal to 2, I already know the answer. For n equal to 2, I already know the answer. So base case is that case for which you already know the answer. So I would basically, I can use n equal to 2 as a base case. I can use n equal to 3 as a base case. I just have to return an answer for that question, right? For n equal to 2, I already know the answer. So I would not be dividing it into further smaller sub problem. So I would be finding an answer for n equal to 2, and the answer for n equal to 2 would be for this the answer would be equal to 2, right? Okay. So then what we have to do is we would basically make call for n minus 2. N minus 1 for n equal to 3 is n equal to 2. And over here, the call would be made to n equal to 1. Answer for this also we know. This would be 1. Then the next thing that we have to do is, the next call that we are going to make is, we are going to make a call to n minus 3, and my n would become equal to 0. So if there is no staircase, obviously the number of ways would be 0, right? So my answer for n equal to 3 would be 2 plus 1 plus 0, and the answer would be equivalent to 3. The answer would be equivalent to 3. But one thing that we have seen over here is that the answer for n equal to 3 must be equal to 4, right? We have already seen this is my answer for n equal to 3, 1, 1, 1, and then 1, 2, 2, 1, and 3. Nothing wrong about that. So, but here the answer is coming out to n equal to, for n equal to 3, the answer is coming out to 4, right? There is something, we are missing something over here. Let's talk about this part. We have already discussed about n equal to 2, and we have already discussed about n equal to 1. We will basically specifically see the third part that we have pre-assumed, and we are basically directly returning 0. So let me elaborate on that. N is equal to 0. There are no staircases. You have to basically start from where you are standing at some place, and you have to end at that place also, right? So standing, the source and destination are same. How many ways would be there? So in n equal to 0, number of ways would be 1. Let me explain how it is. Right? So if n is equal to 3, what we did was we wanted to find that how many ways in which I can achieve n equal to 3. So I said that you can basically take, first you can take, let me write it this way. So I told that first you can take 1, then you can take another instance of 1, then you can take another instance of 1, right? And similarly, I said that first take 1 and then take another instance of 2, right? And then I said that first take one instance of 2 and then take one instance of 1. And then I said that take one instance of 3. Also, what I didn't say was how many instances of 2 were here? 0. And how many instances of 3 were here? 0, right? And similarly over here, the instances of 3 were 0. And similarly over here, the instances of 3 were 0. And over here, the instances of 2 were 0. And instances of 1 were 0, right? Similarly, by the same logic, I can say one thing. I can say one thing. What I can say is that for n equal to 0, there is one way. There is one way where the number of instances of 1 are also equal to 0. The number of instances of 2 are also equal to 0. Number of instances of 3 are also equal to 0. There is one way with which I can start from source and I can go to destination. That is by doing nothing, by taking no steps. By taking no steps, that is also one way, right? If you want to basically score in a match, if you want to score in a cricket match, one way to score is to get out. One way is to score 0 runs. One way is to not score, right? That is also counted as one way, right? This is one tricky part in this question. So for n equal to 0, number of ways would not be equal to 0. Number of ways would be equal to 1, because there is one way to go from to basically go when n is equal to 0. There is one way. What is that one way? Do nothing. So doing nothing is also counted as one way. So over here for n equal to 3, the number of steps would be 4. And similarly, the next call that I will make is, I'll make call to n equal to 2. This is a base case. I would return 2 over here. It will make a call to n equal to 1. This is a base case. It will return 1 over here. So for n equal to 4, the answer would be 4 plus 2 plus 1. So the answer would be 7, right? So the two things that I basically wanted to focus over here, one thing is that the base case, what will be the base case? The another thing would be that for n equal to 0, when there are no steps, then also there would be one way to complete the ladder. Do nothing. That would be counted as one way, right? So let me talk about this thing in detail. So let's suppose you want to find let me talk about this question only, right? So for n equal to 3, how many ways in which I can go from the first step to the third step? There were 4 ways, right? So we are counting 1, 1, 1. We are counting 1, 2, 1. We are counting 1, 2. We are counting 2, 1. And we are counting 3, right? What are these? These are permutations. These are arrangements, right? So if let's suppose we are not taking arrangements. So if we are not taking arrangements in consideration, so 1, 2 and 2, 1 would be counted as same. So if we are only counting combinations, then the number of ways would be 3. So the number of ways would be equal to 3, because 2, 1 and 1, 2 are basically rearrangements of each other. So let's suppose if somebody tells you that you don't have to count the rearrangements, then basically you would say that the number of steps to go from the bottommost point to the topmost point would be 3 steps only, would be 3 ways only. One is 1, 1, 1, one is 1, 2, and one is 3, right? Over here, what you can see is that let's suppose it is 3, right? So one way is to take 3 instances of 3. One way is to take 3 instances of 1 and to take 0 instances of 2 and take 0 instances of 3. Another way is to take 1 instance of this and to take 1 instance of this and take 0 instances of this. Another way is to take 0, 0 and 1 instance. These are 3 ways to basically find 3, right? Right? If I'm talking about combinations, right? So what we have to do over here is, let's try to change this question to 0. If I change my value of n is equal to 0, so still there would be one way, right? What would be that one way? Everything becomes equal to 0. That would be counted as one way, right? For n equal to 3, there were 3 ways. So for n equal to 0, there would be one way, right? So this is one way that I was talking about. I hope you have understood this part, right? So let me quickly write the base cases over here. So if I quickly write the base cases, so I would write that if n is equal to 0, then my answer would be equal to 1. And similarly, I can say if n is equal to double equal to 1, then also you can quickly say that return 1. Right? So this is the small recursive solution that I was talking about. Right now, my question is complete. Right? Before going into further ahead, what I need to talk about is I just want to go quickly to the chat section. I just want to see if you have understood this part or not. Right? So Parv is saying that he has got it. A user with the username Chashmita Betullah is saying that if n is equal to 1, uh, then we can only take one option. We have only one option because we cannot take 3 steps, right? Yeah, right. For if n is equal to 1, then there is only one option. I can only explore one, right? There is no other way, right? Perfect. Shreya has got it. Everybody has got it. Perfect. Shreya, I hope you have understood this. Okay. Perfect. Let's go. Let's move ahead now. So before moving ahead, I just want to quickly do a small thing. I just want to execute this, and I want to see if the answer is coming correct or not. So let's try to see n equal to 4, the answer is coming 7. Now let's quickly see for n equal to 5, what is the answer? The answer is coming 13, which is correct because n equal to 5, it would be sum of 7 plus 4 and plus 2, right? This is the answer of n equal to 3. This is the answer of n equal to 2. And this is the answer of n equal to 4. So we are getting the correct answer, right? Now let me see. Now let me tell you where exactly this dynamic programming comes into play. So let me quickly draw the diagram for n equal to 7. For n equal to 7, the call would be made to n equal to 6, n equal to 5, and n equal to 4, right? And for n equal to 6, a huge tree would be made. Let me quickly try to make the tree for n equal to 6, right? So this is something that I'll make, right? Let me quickly make for n equal to 5 also. So this would be 4, 3, 2, right? So you will get an idea from here what I'm going to talk about. So I'm not making the whole tree. So what we are going to see over here is that for n equal to 7, we are making call to 6, 5, and 4, right? For n equal to 6, I would again make a call to 5, right? So what we are going to do over here is we are making call to 5 again and again. Similarly, we are making call to 4 again and again. Bigger the number, bigger these repetitive calls. These repetitive calls would basically become too much. They would basically become so much. There would be so many repetitive calls. The answer for this, for answer for n equal to 4 would not change. The answer for n equal to 4 would come as 7 and it would not change. The answer would be same. The same tree would be made again. So we are making the same tree again and again, right? We don't have to make the tree again and again. So what's the answer to this? The answer to this is the first step of dynamic programming. And what is this first step? That first step is called memoization. We don't have to memorize these names. You just have to understand the concept. So what we are going to do is in the same tree, we are going to take a memory with us, right? We are going to take a memory with us and we are going to store the result when it is being asked for the first time. n equal to 6 को सबसे पहले जब पूछा तो उसका आंसर आ जाएगा, हम उसको स्टोर कर लेंगे. So what we are going to do over here is like this is n equal to 7. इसने कॉल लगाया 6 को, 5 को और इसने कॉल लगाया 4 को. ये कॉल लगाएगा 5 को, 4 को और 2 और बेसिकली 3 को. 5 का आंसर यहां से जैसे ही आ जाएगा मैं इसको स्टोर कर लूंगा और दूसरी बार जब वो दोबारा पूछेगा तो मैं उस स्टोर किए हुए आंसर में से रिजल्ट को ले लूंगा. दिस इज द आइडिया दैट आई हैव. सो स्टोर कर लो आंसर को, जस्ट try to calculate it once, then store it. After storing it, what you have to do is you have to use the answer which is stored in the storage. दोबारा से पूरा ट्री नहीं बनाएंगे, right? So we will use from the storage. That's the first idea that I wanted to share. Second is what is the size of the storage? So the size of the storage would depend on the on the storage over here, on the variables that I have over here. राइट सो यहां पर कितने वेरिएबल्स हैं? यहां पे वेरिएबल है 1, So I would use 1D DP. I would be using 1D DP over here. Because basically what I'm doing over here is I'm basically using only one variable, right? So if there is only one variable in the recursive call, what we are going to do is we are basically we are going to take only 1D DP array, right? Okay, perfect. So let's quickly use that storage array over here. So, okay. Let me quickly write this function again, and I'll quickly write staircase memoized, and I'll pass two things over here. One is the array, and the other thing is the variable n, right? So let me quickly form this array as well. Okay, perfect. Now what I'm going to do over here is I'm going to do a small thing. I'm going to add -1 in all the places in the array. So let me quickly do that. So ये छोटा सा काम हमने यहाँ पे कर दिया. So what we are going to do is we are going to array of I, and we are going to write -1 over here. I'll let you know why I'm doing this. So don't worry about why I'm doing this. Just try to follow the lead, right? Okay, perfect. I'm going to change this to this part. Let me quickly change this answer, and let me quickly take whatever I'm writing over here and let me quickly write it over here. So you just have to copy paste this thing, right? Then the next thing that you have to do is you have to write ARR in this as well. Recursive call ke andar you have to make these changes, right? Varna it would make call to this niche wala staircase, right? Okay, let me quickly change the name and let me quickly make call to staircase memoized. Perfect. Now my function is ready, right? So what is happening over here is I'm using a staircase over here. I'm using an array over here, right? So if n is equal to 7, so what I'm doing over here is 0, 1, 2, 3, 4, 5, 6, 7. इतना बड़ा array ले लिया मैंने और हर जगह यहाँ पे -1 स्टोर कर दिया. So what I'm going to do over here is यहाँ पर कॉल लगाने से पहले I would ask क्या वो बेस केस है. If it is a base case, directly return is answer. It's no need to make the whole tree, right? If it's not a tree, if it's not a base case, just ask a simple thing. Array of n, is it double equal to -1? If it's double equal to -1, इसका मतलब इसको solve करने की जरूरत है, right? If it's not equal to -1, then this means that answer for this is already calculated. So if it's double equal to -1, that means इसका आंसर ऑलरेडी कैलकुलेटेड है, राइट? फॉर एग्जांपल यहाँ पर n इक्वल टू 4 के लिए आंसर ऑलरेडी कैलकुलेटेड है और लेट्स सपोज यहाँ पे आंसर मेरा 7 रखा हुआ है. 7 रखा हुआ है, इसका मतलब इसके लिए दोबारा कॉल मत लगाओ. So if array is not equal to -1, if array of n is not equal to -1, I'm going to do a simple thing. I'm going to say return array of n. If array of n is double equal to -1, I'm going to call these three calls. I'm going to make these three calls. Then I'm going to store it like this, right? Int answer equal to x plus y plus z. Then I'm going to say before returning store it. पहली बार calculate किया है ना, तो before returning store it. And after storing, then return answer or array of n. They are both same things. They are both same things. So you can either return ARR of n or you can return answer. Right? This will help me understand. This will help me reduce my complexity. This will help me reduce my complexity to a large extent. So what we can do over here is, let me quickly show you. 7 will make call to 6. Let me quickly show you what will happen over here. So let me quickly take the array like this. So this is the array that I have. So this is 0, 1, 2, 3, 4, 5, 6, and 7. This is the array that I've created. Everything is -1 over here to begin with. And 7 will make call to 6. It will make call to 5. It will make call to 4. It will make call to 3. 3 will make call to 2. 2 will return the answer 2. It will make call to 1. 1 will return the answer 1. It will make call to 0. It will return 1. 3 before returning, the answer of 3 is known. The answer of 3 is 4. So before returning, it will go over here and it will store 4. And then it will return. 4 will make a call to 2. 2 is a base case. It will directly return 2. It will make call to 1. It's a base case. It will directly return 1. So the answer of 4 is known, which is 7. But before returning, it will store over here and it will write 7. Now comes the interesting part. It will return 7. Then it will make call to 3. But 3 will not make the tree. It will directly return from the storage and it will return 4. Right? 5 will make call to 2. It will directly return 2 because it's a base case. Before returning, file will store 13 over here. That's the interesting part. 6 will make call to 5. 5 will directly return 13. 6 will make call to 4. 4 will directly return 7 from the storage. And what will happen is this was 13. 6 will make call to 4 over here, which will return 7. And 6 will make call to 3 over here, which will return 4. Sorry for the scribbling that I've done over here, but the answer for 6 is known, which would be 19 plus 4, which would be 23. And I'll quickly write 23 over here before return. This will return 23. This will make call to 5, which will directly return 13. This will make call to 4, which will directly return 7. So my answer would be, it would be equivalent to, this would be 24. This would be 24 plus 13 plus 7, which would be equivalent to 44. And this would be equivalent to 24, right? So this is how the whole tree would be made, right? So this is how it should have been solved. So we have reduced all the tree that I was making. I have reduced the repetitive calls that I was making. That's something very interesting, right? And हमने एक छोटा सा काम किया सिर्फ. हमने क्या किया? हमने सिर्फ और सिर्फ एक स्टोरेज एरे साथ में रखा. अब मैं एक और इंटरेस्टिंग चीज बताने वाला हूं. दिस इज कॉल्ड मेमोइजेशन, राइट? आपने ध्यान से देखा कि व्हाट आई वाज डूइंग वाज, मैं यही तो कर रहा था. मैंने एक ट्री यहां पे बनाया और उसमें मैंने स्टोरेज एरे का इस्तेमाल किया. यहां पे ध्यान से देखो, इसका आंसर मुझे पहले से पता है, इसका आंसर मुझे पहले से पता है, इसका आंसर 1 है, इसका आंसर 1 है और इसका आंसर 2 है. इन तीनों को सम करके मैं इसका आंसर बना लेता हूं, राइट? फिर इन तीनों का सम करके मैं इसका आंसर बना लूंगा, राइट? फिर इन तीनों का सम करके मैं इसका आंसर बना लूंगा, फिर इन तीनों का सम करके मैं इसका आंसर बना लूंगा और फिर इन तीनों का सम करके मैं इसका आंसर बना लूंगा, राइट? So this would become 44. Perfect. So I can solve this question without using recursive calls. In place of recursive calls, what I can do is I can use the storage array. What I am going to do over here is, यहाँ पे n को solve करने के लिए staircase of memoized, इस function को solve करने के लिए I am doing staircase memoized of n minus 1 plus staircase memoized n minus 2 and staircase memoized plus n minus 3. What I can do is to solve dp of n or to store array of n. What I can quickly do is I can take sum like this, right? Right? I can quickly do these things. Right, this is the iterative solution as Hardy is mentioning. I can quickly do this thing. But over there, I had I had this assumption that the answer for this would come, the answer for this would come, and answer for this would come. Over here, I have to assume that the answer for array of n minus 1, array of n minus 2, and array of n minus 3 would automatically come. Right? I have to assume that the answer for these would automatically come. Right? And obviously, because the answer to these would not automatically come, so for that, what we have to do is we have to start with array of 0. We have to fill array of 0 first. We have to fill array of 1 and we have to fill array of 2. From that will form array of 3. From array of 1, 2, 3 will form 4. So on and so forth will complete the whole array. Right? So let me quickly create the tabulation part as well. Right? There is very interesting thing that we have done over here. The interesting thing that we have done over here is that we have converted and we have created a mapping between recursive call and a storage location, a storage array location. So that is the most important thing that we have to do, right? So let me quickly write the function over here. So rather than going this way, I can quickly solve this question directly using array only. So array of 0, would be equal to 1. Let me quickly fill the answers to the base cases, right? So this would be equal to 1 as well, and this would be equal to 2, right? So now let me quickly apply I equal to 3, I should be less than equal to n, and I plus plus should be my answer. Right now, array of I would be equal to array of I minus 1 plus array of I minus 2 plus array of I minus 3. Right? And I can come out and I can print the answer. My answer would be stored in array of n. That's how simple it is. Right? This is the only code that you had to write. This is the answer to this question. The whole memoization that I was doing, the whole trees that I was making, the whole storage array that I was making, right? I can solve this question directly using these highlighted line of code, right? Right? I hope you have understood this part. Just let me know in the chat section, were you able to see that there is a pattern over here? What was that pattern? So to solve any question of dynamic programming, first I have to solve it using recursion, right? So the first thing that I have to do is by recursion. The first thing that I have to do is apply recursion. After doing this recursion, find overlapping subproblems. Find repetitive calls. So find repetitive calls. After you are able to find repetitive calls, then you have to memoize it. You have to memoize your code, right? You have to memoize your code by applying a storage array, right? After applying the storage array, now the next thing that you have to do is, the fourth thing that you have to do is, you have to tabulate it, right? So how do we tabulate it? You have to make an alignment between the recursive call and the block of the storage array. So how are a recursive call and a block of the storage array connected? You have to see that, right? So once you memorize the code, you would be able to see that. That is something that is very important. And the final step is solve the entire question using storage array. So I would say that the first important step is to solve it using recursion, then find repetitive calls, then create it, then try to solve it using memoization, try to bring an alignment between recursive call and the block of storage array. So what one recursive call means to one block of storage array, how they are mapped, right? And then solve it using storage array using the relations, right? Perfect, perfect, perfect. So Kashish, I would, perfect. I would elaborate on the part, how did I converted my recursive calls to the storage array, right? So what I can see over here is, there is, this was a simple way to solve this question, right? I was able to see the mapping between recursive call and the block of storage array pretty quickly, right? But there is another way to do that, right? There is another way to do that. Let me quickly elaborate on that part. So let me make it, let me comment it out, right? So the thing that we are focusing over here is that how we will create an alignment between recursive call and the block of storage array, right? So let's try to solve it. Okay. So after this part is done, after the memoization call was made, right? After this call is made, and after we return back in the main, so at this point of time, my array block would be completely filled, right? You agree with this part, right? So let me quickly do this part. So the first thing that I'm doing over here is I would start with n equal to 7. So let me quickly take that running example only. So for n equal to 7, what I'm going to do is n equal to 7 would make call to 6. It will make call to 5. It will make call to 4. It will make call to 3. It will make call to 2, 1 and 0. This will make call to 3. This will make call to 2. Similarly, this will make call to 4. And this will make call to 3. This will make call to 2. मैं completely बहुत ही जल्दी पूरा का पूरा tree बना रहा हूँ, memoized code का tree बना रहा हूँ, और n equal to 7 will make call to 5 and it will make call to 4, right? इतना ही करेंगे हम. So हमारे storage array को ये completely fill करके लेके आ जाएगा. पूरा tree बनने के बाद ये मेरे storage array को completely fill करके ला देगा, right? So storage array एक बार ही completely fill हो जाए, उसके बाद हम क्या करेंगे, हम स्टोरेज एरे को प्रिंट करवा देते हैं. So let quickly print a storage array, right? So let me quickly try to print the storage array, right? So let me quickly do that. So we would be able to understand what exactly is the relation if we are able to see the system over here. If we are able to see how exactly are the values stored. So I would print array of 5 and I'll do something like this, right? Okay, right, perfect. Now let me quickly print this part. So let me print it for n equal to 7, right? Okay, so n equal to 7, we can quickly see over here that 44 is a sum of these three values, right? Print the values of the storage array and then try to find the solution. Then try to find the relation, right? It would be easier for you to find the solution once you print the memoized array. So I would again elaborate on this part. What you have to do is, this is the most important step, finding the relation between the recursive call and the block of storage cell. For this, what you have to do is you have to print the storage array. Print the storage array. Print the storage array. Whatever has been populated, using that, print it, right? You would be easily able to see things, that whatever is written with -1, that means there are base cases. These are base cases, and these are the things which were completely filled, right? So this was one important thing that I wanted to share. Kashish, I hope now you would be able to find the relation, and now you would be able to follow these 1, 2, 3, 4, 5 steps, right? Now I would leave it to you. What you need to do now is you need to move to this part. Try to solve the first question, which is minimum steps to 1. Try to solve this first question. As I can see, a lot of people have solved these questions over here. A lot of people have, Satyam has solved all the questions, all the 2 questions. And other people are trying to solve this question. I would want a lot of people to focus on this test and make submissions over here. So this question is very similar to the one that I have solved over here, right? Try to solve this question. Try to solve this question. Just take 5 to 10 minutes and try to solve this question. I'll quickly take doubts which are present in the chat, and I would try to answer those questions. Right. So Jay is asking, will it always be possible to solve is using the storage array, or will there be some cases when it cannot solve? So whenever I was able to solve, whatever question that I have tried so far, I was able to solve using the same methodology of recursion, memoization, and tabulation. Right. Yeah, you would be able to solve it using the final iterative step. There would always be tabulation method. If there is a recursive solution, there would always be a tabulation method. Okay, perfect. Now this is a simple question. This is a question which you all should be able to solve it. I would talk about this question in a little while. I just want each one of you to try to solve this question. Take 5 minutes. It's 8:52 right now, and I would wait until 8:58, right? Let me quickly discuss this question if you want, but I want to give you 2-3 minutes. This is an easy question. You should be able to solve this question. Just move on to the test, and once you move on to this test, try to solve this question. Right. Perfect. The question is very easy. Try to solve this question. I'll give you only 2 minutes. Let's start discussing this question at 8:55. This is an easier question. This is something which is exactly the same way that I was. It's exactly the same replica of the last question. There is not even a single change. Right. So I would wait for another minute and then I'll start discussing this question. I will not execute this question. I would not solve this question. I would just talk about uh, the approach, right? Okay. Just to answer Purushottam, yeah, we have to solve this question. What we have done is, I have kept a similar question to the question that I've just explained. So let me discuss this question now. This first question, minimum steps to 1, is the question that I wanted you to solve, right? So let me quickly discuss this question for you. So the question is that you are given n, right? And what you have to do is you have three options. Either you can take one step down, right, and if n is divisible by 2, you can quickly reach to n equal to n by 2. If n is divisible by 3, you can quickly reach to n equal to n by 3. You have to tell that what is the minimum number of steps in which you can reach to 1. Okay, I understood the question, and now let me quickly move to the part over here, and now let me quickly discuss this question. Just to answer your question, Yogesh, the test link is in the description. The test link is in the description. I would ideally recommend all of you to go to the description test link, and let me quickly show you that description link again. So as you will go over here, this is the link to the test. As soon as you click over here, you will reach at this spot, right? Okay, perfect. Let me discuss this question now. So as you can see that n is given to me as 7. N is given to me as 7. For example, n is given to me as 7. So I have three options, right? I have three options. Either I can go to n equal to 6. So let's say that this is also a staircase. So let me quickly make 7 steps for you. So this is 7, this is 6, this is 5, this is 4, this is 3, this is 2, and this is 1. I have to reach to 1. From 7, I have to reach to 1. Currently, I'm standing over here. I have to reach to 1. So I have three options from over here. From 7, I can either go to 6, or if 7 is divisible by 2, I can directly go to 7 by 2. But since 7 is not divisible by 2, I would not be able to take this path. The third step is if 7 is divisible by 3, the third option is then I can directly go to 7 by 3. But since 7 is also not divisible by 3, so I cannot go to 7 by 3. So from here, I can go to only 6, right? From 6, I have three options, right? So I can explore all the options that I have. I have to find number of ways, the minimum number of steps I can go from 7 to 1, right? The answer to the answer to this test case is 3. The minimum number of steps are 3, and that would be equal into फर्स्ट स्टेप में मैं सिर्फ एक स्टेप नीचे आऊंगा, 7 से 6 पे जाऊंगा. फिर 6 से आई वुड डायरेक्टली गो टू 6 डिवाइड बाय 2 विच वुड बी इक्वल टू 3, राइट? और फिर 3 से आई वुड डायरेक्टली गो टू 1 बाय डूइंग 3 बाय 3. सो 3 स्टेप्स के अंदर आई वुड रीच टू 1. दैट इज द आंसर टू दिस सैंपल टेस्ट केस. And I'm not going to elaborate on this question. बहुत ही simple question है, right? n से मेरे को 3 calls लगानी है. पहले n-1. अगर n divisible by 2 है तो I'll make call to n by 2. And then if n is divisible by 3 तो I'll make call to n by 3. इसका आंसर x आएगा, इसका y आएगा, इसका z आएगा, right? I have to find minimum of these three values, right? I have to find minimum of एक step तो मैंने यहाँ पे लिया है ना, तो इसका आंसर x आया, इसका आंसर y आया, इसका आंसर z आया. So my answer would be minimum of x plus 1, minimum of y plus 1, and minimum of z plus 1. Minimum of x plus 1, y plus 1, z plus 1. Right? So Purushottam, I am just hinting you towards the approach. So I think इस तरीके से ये easily solve हो जाएगा. Minimum steps to 1, right? So this is one question that I wanted to talk about, right? So as Purushottam is saying, don't elaborate more. So I would not elaborate more. बहुत ही आसान question है. It is exactly the same way that we have solved staircase question. It's very similar to that. In staircase, I was going from down to up. Here, I'm going from above to down, right? Very similar. So just give me a thumbs up if I can move to the next question. Let's quickly see the leaderboard as well. Just let me know if I can move to the next question. I want to move to the second pattern, right? Just give me a hands up, thumbs up, if I can move to the next question. Right. Perfect. So if I could get a quick thumbs up, then it would be really great. Okay, Jay. Okay. Thank you. Thank you. Okay. So let's move to the next question. A little more confirmations, please. Purushottam, Kashish, Hardy. People, if you can quickly give me a thumbs up, then I would like to move to the next question. Okay. Purushottam is saying to wait for 2 minutes. Okay. Purushottam, we are tight on the schedule. I think you would be able to solve this question. Right? Perfect. Right. Okay. This webinar would be available to you to watch again, Atul. No doubt about that. This would be available. Don't worry on that part. Perfect. Now, the next question that I want to solve is I want answers from you as well in this question, right? The next question that I want to solve is longest palindromic substring, right? So let me quickly talk about this question. And in this question, what we are going to do is we would be given with a string. So for example, let's suppose we are given with a string ABC. Let me quickly see the test case that I have taken. So it's ADBCA, right? So this is the test case that I have. So I have to find longest palindrome substring. Let's try to solve this question. Right? I have to solve longest palindromic substring. I don't have to find the longest palindromic substring. I have to find the length. So find the length of the longest palindromic substring. Whatever we have learned so far in the first question, we are going to apply it over here. So we have to find the length of the longest palindromic substring. You know what is palindrome? Anything which is same from ahead and behind. So for example, Nitin is a palindrome, right? So similarly, over here, palindrome I have already understood. I think you know what is a substring. Substring is a continuous set string, right? A continuous set of characters. Like for example, A is a substring, then AB is a substring, ABD is a substring, ABDB is a substring. So a continuous set of characters would be a substring. So I have to find the length of the longest palindromic substring, right? So what is the longest, or what is the length of the longest palindromic substring? If you can tell me, what is the length of the longest palindromic substring over here? I think the length of the longest substring comes out to be BDB, right? Similarly, let me give you another example. So let's suppose I am given with C, D, D, P, D, right? So now find the longest palindromic substring in it. So quickly tell me what would be the longest palindromic substring in C, D, D, P, D. What would be the longest palindromic substring? Right? Obviously, the length would be 3 over here. What would be the answer over here? What would be the answer, and what would be that substring which has the which is the longest palindrome? Right? Okay. So over here, it would be DPD, right? So it would be DPD as RF is rightly mentioned, and the answer would be 3. Perfect. Perfect, perfect, perfect. We have to find the length of the longest palindromic substring, right? Now let's try to solve this question. Take 2 minutes, try to find this, try to solve this question. How would you solve this question? First, try to solve it recursively. बिल्कुल दिमाग से सारी चीजों को निकाल दो, अज्यूम करो कि जो मैं सब प्रॉब्लम बनाऊंगा उसका आंसर आ जाएगा। सब प्रॉब्लम से सॉल्व करने की कोशिश करो, रिकर्सिवली सॉल्व करो सबसे पहले। सो मैं ये आपसे सॉल्व कराना चाहता हूं, राइट? स्ट्रिंग s is given to you and I'll give two more variables. I would give you starting index and I'll give you ending index. So to begin with, what I'll give you, let's suppose I want to find the answer. So in S, I'll send A, B, D, B, C, A, and in the starting, let's make it st and let's make it ed. So in st, the variable which would be sent would be 0, and in ed, the variable which would be sent would be 5. Right? I want to find the longest palindromic substring in the string which starts at 0 and which ends at 5th index. Right? Substring के अंदर we don't leave any character, पुरुषोत्तम. सो बाकी लोग एक बार इसको अप्लाई करने की कोशिश करो, ट्राई टू सॉल्व दिस क्वेश्चन, राइट? यहाँ पे एस की वैल्यू कितनी है? ए बी डी बी सी ए, राइट? एस की वैल्यू ये है, एंड द क्वेश्चन दैट आई एम आस्किंग ओवर हियर is find the longest palindromic substring in the string which starts at 0th index and which ends at 5th index, and the value of the string is a b d b c a, right? This is the question that I'm asking for. इसको सॉल्व करने की कोशिश करो. What should be the sub problem that I should take over here? What should be the answer of the sub problems? Right? वो एक बार सोचो, थोड़ा सा सोचो इसके ऊपर. मैं पुरुषोत्तम के कमेंट का आंसर कर देता हूं. पुरुषोत्तम, यहाँ पे डी 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 नहीं हो सकता, बिकॉज सबस्ट्रिंग के अंदर आपको कॉन्टिन्यूस कैरेक्टर्स लेने पड़ते हैं. डी डी ली लेने के लिए आपको बी को छोड़ना पड़ेगा. सो आई कैन नॉट लीव P over here, right? So that's why my longest palindromic substring would be DPD. Perfect. अब ये वाला जो रिकर्सिव फंक्शन है ये आपको लिखना है. इसको सोचो कैसे सॉल्व करोगे. थोड़ा सा खुद से सोचने की कोशिश करो किस तरीके से इस प्रॉब्लम को सॉल्व करोगे. अगर किसी ने आपको ये प्रॉब्लम दे दी, लॉन्गेस्ट पैलिंड्रोमिक सबस्ट्रिंग बताना है, गिवन स्ट्रिंग इज S, it starts at ST, ends at ED. थोड़ा सा हिंट दूं, अगर आप चाहते हो तो मैं थोड़ा सा हिंट आपको दे सकता हूं. सो जस्ट लेट मी नो इफ यू वांट सम हिंट्स. थोड़ा अपनी तरफ से कुछ पिकअप करने की कोशिश करो, थोड़ा अपनी तरफ से कुछ कमेंट डालने की कोशिश करो. बहुत बढ़िया. समीर हैज रिटन समथिंग. सो समीर हैज सेड दैट इफ ST इज डबल इक्वल टू एंड, सो जो करेक्टर स्टार्टिंग पे और एंडिंग पर है अगर वो बराबर है तो इनर के लिए देखो, चेक करो, वरना मैक्स ऑफ ST प्लस 1 कोमा एंड कोमा ST कोमा एंड माइनस 1. समीर ने एकदम एग्जैक्टली सही बोला है, एग्जैक्टली जैसे प्रॉब्लम को सॉल्व करना चाहिए. लेट मी एक्सप्लेन व्हाट एग्जैक्टली समीर इज टॉकिंग अबाउट, राइट? सो इसको थोड़ा सा यहाँ पे रखते हैं और इसका बात करते हैं. सो आपको यहाँ पे तीन चीज दे रखी है. आपको यहाँ पे बोल रखा है कि S है आपके पास और स्टार्टिंग वर्टेक्स है और एंडिंग वर्टेक्स है, राइट? सो यहाँ पे स्टार्टिंग वर्टेक्स है और एंडिंग इंडाइसिस है. सो स्टार्टिंग और एंडिंग इंडाइसिस है और आपको स्ट्रिंग दे रखा है. सो स्ट्रिंग आपके पास क्या है? स्ट्रिंग इज A B D B C A. सो अब मुझे बताना है, यहाँ पे 0 है, यहाँ पे 5 है वैल्यू टू बिगिन विद, और स्ट्रिंग का मेरा वैल्यू यहाँ पर क्या है? A B D B C A, राइट? सबसे पहले मैं यहाँ पर पूछूंगा इससे, क्या आगे और पीछे वाली वैल्यू बराबर है? अगर आगे और पीछे वाली वैल्यू बराबर है तो देन द मैक्सिमम सबस्ट्रिंग दैट आई कैन गेट इज बेसिकली, अगर आगे और पीछे वाला बराबर है, स्टार्टिंग और एंडिंग पे जो कैरेक्टर्स रखे हैं अगर वो बराबर हैं, तो आई वुड ओनली चेक फॉर द इनसाइड स्ट्रिंग. सो मैं यहाँ पे एक छोटी सी बात बोलूंगा, अगर स्टार्टिंग और एंडिंग वाला बराबर है तो सिर्फ बीच वाले के लिए चेक करो. कैसा कॉल लगेगा बीच वाले के लिए? बीच वाले के लिए कॉल ऐसे लगेगा, S की वैल्यू तो चेंज नहीं होगी, S की वैल्यू तो वही रहेगी, A B D B C A. मैं यहाँ पर चेंज करूंगा इसको. सो मैं चाहता हूं कि ये इतने वाले को कॉल चली जाए, B D C B C को चली जाए, B D B C को चली जाए वैल्यू. सो इसके लिए मैं क्या करूंगा, st की वैल्यू बढ़ा दूंगा और end की वैल्यू को एक कम कर दूंगा 1,4. सो आई वुड से जैसे कि आपकी पूरी की पूरी स्ट्रिंग ये है, so make a call, find the longest palindromic substring of the string which starts at index 1 and ends at index 4. इतना सा बात बोलूंगा, राइट? और यहां से इसका आंसर मैं आई वुड रिटर्न बैक द आंसर फ्रॉम हियर. सो व्हाट वुड बी द आंसर? इसका आंसर होगा बीडीबी. इसका आंसर क्या होगा? इसका आंसर होगा 3, राइट? ऑब्वियसली अगर मैं किससे पूछता हूं बीडीबीसी, इसका लॉन्गेस्ट पैलिंड्रोमिक सबस्ट्रिंग का लेंथ बताओ, तो ये मेरे को क्या रिटर्न करके देगा? 3 रिटर्न करके देगा, राइट? सो मैं एक काम करूंगा, व्हाट आई वुड डू इज, मैं देखूंगा कि क्या पूरी की पूरी इनर सबस्ट्रिंग पैलिंड्रोम है. इज द ऑल द इनर सबस्ट्रिंग दैट if all the inner substring that I've sent as a recursive call, if the complete inner substring is a palindrome, then obviously the starting and the ending character are also same. Inner substring is also palindrome, so my complete string is palindrome, right? So मैं यहाँ पे बोलूंगा BDBC, इसकी वैल्यू बताओ, कितना बड़ा पैलिंड्रोम है इसके पास? इसके पास 3 है. लेंथ कितना है इस पैलिंड्रोम का? लेंथ कितना है? 4 -1 -1, राइट? सो इसका लेंथ कितना है? सॉरी, इसका लेंथ कितना है? यहाँ पे इसका लेंथ हो जाएगा 4 -1 +1, सॉरी, राइट? सो यहाँ पे अगर मुझे किसी ने बोला 0 1 2 3 4, स्टार्ट होने वाली 1 पे, एंड होने वाली 4 पे, इस पूरी की पूरी सबस्ट्रिंग का आप लेंथ बताओ तो कितना हो जाएगा? 4 माइनस, इट वुड बी एंड माइनस स्टार्ट प्लस 1, राइट? सो इट वुड बी इक्वल टू 4. सो पूरा सबस्ट्रिंग का लेंथ कितना था? 4. एंड लॉन्गेस्ट पैलिंड्रोमिक सबस्ट्रिंग का लेंथ कितना था? 3. यानी पूरा का पूरा सबस्ट्रिंग पैलिंड्रोम नहीं है. सो मैं इसके आगे ए और ए का जोड़ नहीं सकता. ए और ए को यूज तभी कर सकते हैं when the entire inner substring is a palindrome. So the first case is of no use to me. Then what I'll do is I'll make 2 calls. अगर पूरा का पूरा substring palindrome नहीं है, तो what I'll do is try to find answer for AB, DB, C. इतने का find करके देखो. So अगर पूरा का पूरा palindrome नहीं है, so what I'll do is मैं बोलूंगा कि इतने का फाइंड करके देखो. पूरा पैलिंड्रोम नहीं है तो इतने का बताओ मैक्सिमम कितना होगा. पीछे से एक कैरेक्टर हटा दो. सो आई वांट टू मेक इट अ लिटिल स्मॉलर. ऑब्वियसली द फर्स्ट कैरेक्टर एंड द लास्ट कैरेक्टर आर नॉट इक्वल. सो व्हाट आई विल डू इज आई विल रिमूव द लास्ट कैरेक्टर वंस एंड आई वुड से फाइंड द लॉन्गेस्ट पैलिंड्रोमिक सबस्ट्रिंग ऑफ दिस स्ट्रिंग. द लॉन्गेस्ट पैलिंड्रोमिक सबस्ट्रिंग फॉर दिस स्ट्रिंग वुड बी 3, which would be BDB. Then I'll again say find the longest palindromic substring for this part. So this would be the longest palindromic substring for this part would also be BDB, which would also be 3. So I would make these 2 recursive calls. Why I would make these 2 recursive calls? Because of the fact that that I was not able to find the answer from the first and the ending. First and ending were equal, but the inner substring was not palindrome. So I would make 2 recursive calls over here. What would be those 2 recursive calls? It would be equal to A, B, D, B, C. At the end, it would be A, and I would make call to start plus 1 comma end, which would be equal to 1 comma 5. Another recursive call that I would make would be A, B, D, B, C, A, comma 0, comma 4. I would find the maximum over here. The maximum from here would be 3, and the answer from here would be 3. I would find the maximum of both of these values. So my maximum is 3. So my answer would be 3 in this case. This is how I will solve this question, right? And as Mohammed is rightly pointing, it's saying that if is palindrome, if the inner is a palindrome, then return the length of that palindrome, right? And else it is making 2 calls, which is st plus 1 comma ed, and the other call it is making is st comma ed minus 1. So as Mohammed is rightly pointing, one mistake that he's doing is he has to check if the inner substring is a palindrome or not. So for inner substring, the call has to be made to st plus 1 comma ed minus 1. If my substring starts from st comma ed, the inner substring would be starting from st plus 1 comma ed minus 1. And I'll make call to the inner substring only when the character at st and ed are equal. And I'm not making a call. I'm not making a call. I'm not making a call over here. I'm not making an is palindrome call over here, right? What I'm doing is I'm taking the answer from the recursive call. I'm saying that find the answer for the recursive call. If the answer of the recursive call is equal to the length of the substring of the recursive call, answer is 3 over here. If the length of the substring also would have been 3, that would mean the whole substring is a palindrome. If it's a palindrome, then I don't have to make a function call like Mohammed is making. I would simply ask him, what is the answer? Answer is 3. What is the length? Our length A over here is 4. So that means the whole substring is not palindrome. The inner substring is not palindrome. Right? So this is the main objective of the question. This is how I'll solve this question. Let me quickly move to the implementation part. I hope you have understood this part. So let me quickly move to the implementation part. Okay, so let me quickly comment the staircase part. I hope you have understood, Purushottam. If you have understood, I would like to move to the next part. Or what we can do is, let me write the implementation. I'm sure you will be able to understand this part. Right? Perfect, perfect. I just wanted to minimize it, but I'm not able to minimize. Okay. Okay, perfect. No doubt. Right, let's move ahead. So what I'm going to do over here is I'm quickly take the input of this string, which would be sen.next. Okay. I will quickly take the input, right? And after taking the input, what I'm going to do over here is, Purushottam, as I'm implementing this question, you would be able to understand through implementation as well. I'll take another example as well, right? So, okay, let me quickly implement it first from the method that I have talked just now. So let the function be LPS. Let me pass S, let me pass 0, and let me pass S dot length minus 1. Right? So this is how I'll pass these things. Let me quickly minimize all the other functions that I've written. Okay, okay, and perfect. Okay. So let me quickly change this value to int. Right? I hope you have understood this part. First, what I'm doing is I'm trying to apply the same methods. First, I'm trying to solve it recursively. After that, what I'll do is after that I'll apply memoization, and then at the end I'll do tabulation. So okay, now what we have to do is the first thing that we have to do is I have to ask that if the s dot char at the starting index and the end index, are they equal or not? So let me quickly change the name of the variables. So this would be st, and I'm asking whether this value is equal to the ending part or not. If they are equal, then I'll find the remaining length. So let me quickly find the remaining length, the length for which I'll make a recursive call. So the remaining length would be equal to ed minus st plus 1, right? As we have rightly seen, this would be ed minus st plus 1. Perfect. Okay. So then what we have to do over here is, now let me basically quickly make a recursive call. Okay. So my recursive call would be int answer of my inner string. Now I would make call to the inner string. And my recursive call would look something like this. It would become st plus 1 and it will become ed minus 1. So if my answer is double equal to remaining length, if both of these values are equal, then my answer would be, I'll directly return. What would be my answer? My answer would be answer plus 2. My answer would be answer plus 2. Whatever what was the answer for my inner substring, I'll add 2 to it. One for the starting character and one for the ending character. This condition means that the inner substring, the complete inner substring is a palindrome, right? So if this is the case, I have to directly return it. I don't have to do anything else. If this is not the case, then I would express my choices. So the first choice that I have to express would be, I would quickly go and I would say that make a call to st plus 1, comma ed, find the longest palindromic substring between these two values, and the choice 2, which would be find the longest palindromic substring for the string which starts at the starting vertex and which ends at ed minus 1, right? Then my answer would be the maximum of these two values, right? So let me quickly write. It would be maximum of these two values. One is ch1 and other would be ch2, right? This is the recursive code that I was talking about. Now let's try to write base cases to this code, right? So the base cases would be very simple. So the one base case would be if s is double equal to e, if the starting character, if the starting index is double equal to the ending index, then I would directly return 1. Because if st is double equal to ed, that means it is pointing to a string which only has one character, right? Similarly, another case that I wanted to talk about is if my st overshoots ed, then it is not pointing to a valid string. Then it's not pointing to a valid string and I can directly return 0, right? Then I can directly return 0. So this is the code that I was talking about. The code is fairly simple. There is nothing in this code. Now let me quickly run this code for a simple test case, right? Let's quickly run this code for a sample test case and let's see if our code is correct or not. So let me write it. Let me write the test case that I was talking about. So the running example that we are talking over here is A, B, D, B, C, A, and the answer for this is coming out as 1, right? So this is something which is coming out as wrong, right? Okay. Why exactly the answer for this is coming out as wrong? Okay. Answer, I think I've done it correctly. I've checked the starting character and the ending character. And then if this is not the case, what I'm doing over here is I'm making 2 recursive call and then I'm finding the maximum of these 2 recursive call and I'm returning it, right? So as Samir is rightly pointing out, there is some mistake that we are doing over here, right? Let's quickly check this part again. Let's quickly check this part again and I'll do it over here as only. So let's suppose we have A, B, D, B, C, A, right? Both of these characters are equal. So my remaining, so over here, my ED would be equal to 5 and my ST would be equal to 0, right? And I want to find, this is my ED, my ED is 5 and my ST is 0, right? Right. So over here, what we have to do is we have to find the remaining length. So my remaining length would be equal to, obviously it would be equal to ED minus ST minus 1. So we are doing it wrong. It should be minus 1 over here. Why it should be minus 1? It's pretty intuitive, right? I have to subtract from ED, I have to subtract ST. This counts, this counts 1 less. I would subtract 1 more to exactly count the length of the remaining string. I would subtract 1 more to exactly count the inner substring, the length of the inner substring. So the length over here should be ED minus ST minus 1. Right, exactly, right. Thank you, Samir, for correctly pointing out. A, B, D, B, C, and A. And the answer is now coming out to 3. Now let's take another example. So let's take A, B, C, C, B, and let's name it D, right? So what would be the answer to this? I think the answer to this should be 4. And the answer to this is coming out as 4. So the answer for A, B, C, C, B, D is coming out as 4 for B, C, C, B, right? Exactly the way it should be, right? I hope you have understood this part, right? Purushottam, just let me know quickly in the comment section if you have understood this part or not. I think now you should understand this part. We have written this code. Perfect, Samir. Thank you. Okay. Moving ahead, now what we have to do is we have written the recursive code, right? We have written the recursive code. I have to memoize it. I have to memoize it. Now let's try to memoize it. So for memoization, what I'll do is I'll find the number of variables that I have. How many variables do I have over here? I have two variables. That means I'll use 2ddp. That's the interesting part that I'm doing over here. So I'll have 2ddp over here. Okay. So let's name the storage array as dp. And then let's quickly do over here, right? So I have understood that the size or the dimensions would be 2. There would be 2 dimensions. Now let's talk about what would be the size of the dp, right? I want to make sure that each and every value of my variable should be there. So there are 2 variables. One variable is st, other variable is ed, right? So how st is varying? St is varying from 0 to st dot st is varying from 0 to 5. St is varying from 0 to s dot length minus 1. Similarly, ed is varying from 0 to 5, right? It is both of these values are varying from 0 to 5. So I want that 5 should be over here, and similarly 0 to 5 should be over here. So if I want to create a board of something like that, so what I will do is I'll create a board which would have st.length plus length plus 1 number of rows and st.length plus 1 number of columns, right? So I have to understand the dimensions of the storage array. I hope you have understood the dimensions of the storage array, right? So it would be s.length plus 1, and the number of columns would also be equal to s.length plus 1. So the two questions that I have to ask myself before deciding the length, the dimensions, the first variable would be that how many variables are there. The first question would be how many variables there are. There are 2 variables, so 2ddp, right? Second question is how are those variables varying? One variable is going from 0 to s dot length minus 1. The other variable is going from 0 to s dot length minus 1. So my rows would be s dot length plus 1, and my variable and my columns would be 0 to s dot length minus 1, right? So for that, what I've done is I've written something like this, right? Okay. By default, each and every block, in dp in the storage array would be equal to 0. What Java does is Java fills each and every block with 0, right? So let me quickly build this block like this, right? So I've created this block and I've created it for s dot length plus 1. So the length of s is 6 and plus 1, it would become 7. So I would basically, I've created for 0 to 6. Even if I create it only for s dot length, then also it will work, right? Then also it will work. I hope you understand this part. I don't have to keep the dimensions equal to s dot length plus 1. Even if I keep it s dot length, then also it will work. So let me quickly make the 2D array over here. Perfect. Yeah, perfect, right? So now once I've done this part, then what I'll do is each and every block has a value of 0. Each and every block has a value of 0. So I can do one simple thing over here. And as soon as I do that one simple thing, you would be able to understand how easy it is to implement DP, right? So let me quickly add this in the dimensions over here. Let me quickly do this over here. Let me add this DP array to each and every recursive call that I have. Let me quickly do that. Let me quickly do that. I've done that. Now let me add another question over here, right? So I would ask that if dp of st comma ed, if it is not equal to 0, right? Let me make it -1. If it is not equal to -1, that would mean that it has been already filled, right? Or what we can do is we can make it 0 as well, because the answer will not be 0 for any question. Let me again reiterate this part. For any substring, the answer would either be 1. For example, if I take A, B, C, D also, what is the longest palindromic substring for this? This would be at least 1. The answer for all the substrings that I have, the least longest palindromic substring for any substring in the world would be 1. 1 क्यों होगा? अगर सारे के सारे यूनिक कैरेक्टर्स हुए तब भी एटलीस्ट एक लेंथ का तो मेरे पास होगा ना स्ट्रिंग. सो एक लेंथ का मेरे पास सबस्ट्रिंग होगा, इसलिए मैं मिनिमम को 1 मान लेता हूं. सो कभी भी मेरा 0 आंसर नहीं आएगा. सो अगर मेरा dp of sted is not equal to 0, then I can say my answer is basically already solved. अगर dp of sted की वैल्यू 0 है तो this is the first time that I am solving that. If it is not equal to 0, that means I've already solved it. Right? So these are the two things that I wanted to talk about. And I can directly return dp of sted if it is solved like this. If it is already solved like this, then I can basically quickly write it like this, right? And if it is being solved for the first time, then I can store it before returning. So I would store before returning. What I would do is I would store before returning. And after doing that, what I'll do is I'll return dp of sted. Storage is very important before returning. Storage is very important before returning, right? So this is how we would convert a recursive solution into a dp solution, into a memoized solution. Very easy, right? Let me quickly see if the answer is coming correct now also. So let me quickly see what would be the answer now. So let me see the answer for A, B, C, C, B, D. So A, B, C, C, B, D. Let's see. The answer should be 4 now also. The answer is coming out as 4, right? Let's see the answer for more test cases. So A, B, D, B, C, A. The answer should be 3. The answer is still coming out as 3, right? Now we have to convert it into tabulation, right? The next step that we want to do is we want to convert the solution into tabulation. We have already solved it. Now we have to convert it into tabulation. So I want to stop over here for a few minutes. I want to ask whether you have understood up till this part or not. Then we'll move to the next step, right? Right. So Samir, I did get your answer. You're saying that I've forgotten to add memoization. I've added memoization everywhere, right? I've added memoization everywhere. So what exactly do you mean by the fact that I've forgotten to add memoization? By adding memoization means I want to add value stored, right? So I want to by adding memoization means that I am using a storage array. Storage array use किया है तो memoization आपने लगा दिया. Okay. Got it. यहाँ पर आपका आएगा. I agree. Thank you. यहाँ पर भी आपका memoization आएगा. Thank you. The quality of questions that you ask determines that you have understood this part. Kashish has asked some question. Kashish, I'm answering to a question. ठीक है. So Kashish पूछ रहे हैं कि why max of CH and CH1 plus CH2 is stored in DP. DP में तो इसलिए store किया है ना Kashish, because of the fact that I have seen the answer to this question, right? I've calculated the answer to the question. If the answer is again asked, अगर वही क्वेश्चन दोबारा पूछा जाता है, अगर वही रिकर्सिव कॉल दोबारा बनाने को कोई मेरे को बोल दे, तो मैं उसको स्टोरेज एरे से सॉल्व कर दूंगा, राइट? सो आंसर रिटर्न करने से पहले मैं उसको डीपी में हमेशा स्टोर करूंगा, राइट? सिंपल, एज सिंपल एज दैट. अभी CH1 और CH2 का मैक्सिमम क्यों डीपी में स्टोर किया? बिकॉज CH1 और CH2 का मैक्सिमम आंसर है, एंड आंसर को रिटर्न करने से पहले स्टोर कर दो, राइट? ओके, परफेक्ट. अब जो आंसर कशिश ने पिछली बार पूछा था वही यूज करेंगे. कशिश ने बोला था कि मेमोइजेशन से टैबुलेशन की तरफ कैसे मूव करोगे. सो मेमोइजेशन से टैबुलेशन की तरफ मूव करने के लिए कशिश, मैंने आपको बताया था कि अपना डीपी एरे को प्रिंट कर दो और उससे अपने आप आइडिया लग जाएगा कि टैबुलेशन कैसे बनेगा. सो प्रिंट कर देते हैं अपना अपना डीपी एरे तो कंप्लीटली फिल होके आ चुका है. सो वी हैव कंप्लीटली फिल्ड आवर डीपी एरे. सो नाउ लेट अस क्विकली जस्ट प्रिंट दिस पार्ट. सो इफ आई प्रिंट दिस पार्ट, what I can see over here is I want to print this DP array, right? Whatever it has filled, right? It has been printed. It has gone through the complete recursive tree. And let me see. Let me see what would be the answer to this. What are the values which are stored over here? Then we would be able to find the relation. Then we would be able to find the relation over here, right? Okay. Okay, I'm making a small mistake. Perfect. Now it's perfect. Okay. Right. And now I want to print the value. So my value would be dp of I j. And I want to print a space over here. Wherever the value would be 0, that means it's a base case, right? Wherever the value would be 0, it would be a base case. Now let's quickly print this value. Now let's print it for A, B, D, C, A. Let's quickly print it for A, B, D, C, A. A, B, D, B, C, A. Okay. So the value that is stored over here is this, right? So let me quickly populate it over here. So the value which is stored over here is 0, 1, 1, 3, 3, 3. Over here, the value which is stored is 333 as well. Over here, the value is 111. Over here, it's 1, it's 1. Over here, it's 1. And similarly, over here, it's 1. And similarly, over here, it's 0. Everything over here is 0. Right? So let's quickly locate the values that we were trying to find. So if I try to locate the values, so what I can see over here is that one thing that I can see over here is, okay. So these are the base cases for me, right? क्योंकि यहाँ पे ST और ED की value equal है, right? So this is this base case. This is 0, 0. This is 0. This is 1, 1. This is 2, 2. This is 3, 3. And this is 4, 4. And this is 5, 5. मेरे को base case मिल गया. Everything over here, ये भी मेरा base case है. यहाँ पे देखो. Try to go to any block that you see. Let's go to this block. So what we can say over here is that this is 0 over here. So the coordinate over here is 3, 1. ST's value is 3 and ED's value is 1. So ST is greater than ED. So at that point of time, that is also a base case. So what we can say is that this is also a base case. Now, obviously, my answer is stored over here. I can see that my answer is stored over here. So now what I can say over here is, let's quickly try to find a relation over here. Right? Let's quickly try to find the relation of the recursive call and the relation that it is stored over here. So my answer is stored over here. My answer is dp of 0, 5. My answer is dp of 0, 5, or my answer is dp of 0, st dot length minus 1. Right? So what I can say over here is, okay, so what I can say over here is that अगर आगे का करेक्टर और पीछे का करेक्टर दोनों बराबर है, right? So it will go to its inner part. So this is the inner part, right? It will go to the inner part and it will find जो अंदर वाले का part है उसका आंसर मेरा किसके बराबर होगा, right? So अंदर वाले का मेरा आंसर किसके बराबर है? 3 के बराबर है. और अंदर वाले में मेरी स्ट्रिंग्स कितनी है? अंदर वाले में मेरी स्ट्रिंग्स किसके बराबर है? स्ट्रिंग का लेंथ कितने बराबर है? 4 के बराबर है. और अंदर वाले का आंसर कितना है? 3 है. यानी अंदर वाला कंप्लीट पैलिंड्रोम नहीं है. अगर अंदर वाला कंप्लीट पैलिंड्रोम होता तो अंदर वाला +2 मेरा आंसर हो जाता, राइट? जैसा इसमें यहाँ पे लिखा हुआ है. अगर अंदर वाला मेरा कंप्लीट आंसर नहीं है, देन आई एम गोइंग टू ST + 1 एंड ED एंड आई एम गोइंग टू ST, ED - 1. तो ये मेरा ST, ED - 1 है और ये मेरा ST + 1, ED - 1 है, right? So the thing that I have understood over here is that, let me quickly move to this part. The thing that I have understood over here, that dp of ij के लिए सबसे पहले ये पूछना है कि i पर रखा हुआ कैरेक्टर j के रखे हुए कैरेक्टर के बराबर है या नहीं. अगर i और j अगर बराबर हुए, then what I'll say is that find the answer which is stored at the internal string, which is I plus 1 j minus 1. इसका आंसर फाइंड किया, लेंथ फाइंड करो इसका, लेंथ कितना होगा, लेंथ would be equal to j minus I minus 1, similar to the way it was ed minus st minus 1. अगर लेंथ भी बराबर आता है, अगर लेंथ बराबर आता है dp of I plus 1 j minus 1 के बराबर, तो मेरा आंसर हो जाएगा this length plus 2. So मेरा आंसर हो जाएगा length plus 2. If this is not the case, then what I have to do is, the second thing that I have to do over here is, I have to find maximum of dp of I plus 1 comma j. I have to find maximum of dp of I plus 1 comma j and I comma j minus 1. This is the, I have to find maximum out of these two values. I have to find maximum out of these two values. यहां से आंसर आता है तो आंसर लेंथ प्लस 2 हो जाएगा, यहां से आंसर नहीं आता तो मेरा आंसर मैक्सिमम ऑफ दीज टू वैल्यूज हो जाएगा. राइट जस्ट लेट मी नो इफ यू हैव अंडरस्टूड दिस पार्ट और नॉट. ये रिकरेंस रिलेशन निकालना बहुत इंपॉर्टेंट है, ये रिकरेंस रिलेशन निकालना बहुत इंपॉर्टेंट है. एक बार हम रिकरेंस रिलेशन निकाल लेते हैं, उसके बाद हम अपनी पूरी की पूरी प्रॉब्लम को सॉल्व कर पाएंगे. I would discuss this question ahead once you give me a thumbs up that you have understood this recurrence relation. Just let me know if you have understood this recurrence relation or not. Let's pause for a while and let me know if you have understood this recurrence relation or not. Just a thumbs up would do. Perfect. Thank you, Kashish, for the confirmation. Perfect. So ये recurrence relation आपको समझ में आ गया है. A few more confirmations would really help. We are 35 people right now. Sameer, if I can get confirmation from you. Okay. Perfect. I would like to move ahead. Okay. So dp of ij, this is the recurrence relation that we have created so far. Okay. Thank you, Sameer. Then let's try to solve this question now. Right? So again, what we have to do is, one thing that we have to do is, before solving dp of ij, we should have answers to dp of I plus 1 j, I comma j minus 1 and I plus 1 j minus 1. So if I want to find the answer to I comma j, I should already have the answer to these three values. If I have the answer to these three values, then only I would be able to find the answer to this. That's the another important thing that I wanted to talk about. Right? Perfect. So let's quickly talk about these values. Okay. So let me quickly make that 2D DP again. Okay. Okay. Just give me a second. I'll quickly make this. Okay. Perfect. Now let me write the indices over here, which is 0, 1, 2, 3, 4, 5. And here it is 0, 1, 2, 3, 4, and 5. Right? So obviously, first what we will do is we will fill the base cases. What are the base cases? For me, the base cases are all these places. All these places where ST is greater than ED. All those places where I is greater than J. I will write 0 at those places. In Java, I don't have to worry about writing 0, because already by default, 0 is filled over there. Right? Now what I should do is, where ST is double equal to ED, I should fill that place. So I should write 1, 1, 1 over here. Right? So I should write 1, 1, 1 over here. Right? So I should quickly move to these places. So first I should move to 0, 0, 1, 1, and I should move to 2, 2, 3, 3, 4, 4, and 5, 5, and I should write at 1 or at all the places, right? Then I should move to places where the length of the substring is equal to 2. That means I should move to 0, 1, I should move to 1, 2, 2, 3, 3, 4, and 4, 5. Just try to understand this part. I'm moving at these characters like this. I'm moving in this line. Let me change the color and then let me show you this. I'm moving in this line. all the substrings are of length 2 in this line, right? Because why I'm doing this part? Because when I'm solving this line, when I would solve this line, I would want answers to this, I would want answer to this, and I would want answer to this. So first I'll solve this line, then I'll solve this line, then I'll solve this line, then I'll solve this line, right? Then I'll solve this line, and then I'll solve this line. This is the most important thing that I wanted to talk about, right? So first I'll solve this first line, then I'll talk about the second line, then I'll solve the third line, then I'll talk about the fourth line, then I'll talk about the fifth line, then I'll talk about the sixth line, right? In the second line, the characters that I have, the value of ij would be 0, 1, 1, 2, 2, 3, 3, 4, and 4, 5. In the line 3, the indices that I would basically start would be 0, 2, 1, 3, 2, 4, and it would be equal to 3, 5. Similarly, in the line 4, it would be equal to 0, 3, 1, 4, 2, 5. In line 5, it would be equal to 0, 4 and 1, 5. In line 6, there would be only one character. There would be only one block, and it would be equal to 0, 5. Right? I hope you can see this part. Right? Now, if I want to generalize it, if I want to populate it, what I can quickly do is, what I can quickly see is that to begin with, my value of s is always equal to 0. Right? Let's talk about the variables that we have been using so far only. So the variables that we have been using is I and j. So to begin with, the value of I is 0 everywhere. Over here also it is 0. 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 0, 0, 0 is everywhere. And the value of the j is length minus 1. Right? So this is 1 length substring, this is 2 length substring, this is 3 length substring, this is 4 length substring, this is 5 length, and this is 6 length substring. So to begin with, the value of j is length minus 1, length minus 1, length minus 1, length minus 1, and length minus 1. And then what I'm doing is, after starting with 0, 2, the next value would be I plus plus and j plus plus. The next value would be the incremented value. I would increment I by 1 and I would increment j by 1. And the next value would come. The next value from 0, 2 is 1, 3. From 1, 3, I'll move to 2, 4. I'm incrementing both of these values. Anywhere you can go. From 0, 4, I'm going to 1, 5. From 0, 3, I'm moving to 1, 4. From 1, 4, I'm moving to 2, 5. Similarly, from 0, 1, I'm moving to 1, 2. From 1, 2, I'm moving to 2, 3. I'm incrementing both of these values by 1. I'm incrementing I by 1 and I'm incrementing j by 1. Right? That is the important thing that you have to focus on. Right? So this is how you would traverse. And to solve any one block, you would have to use the same recurrence relation that we have talked about over here. Right? Right? I hope you have understood this part. If you have understood this part, just let me know in the comment section so that I can start with the coding part, so that I can start with the implementation part. Just a brief confirmation would be best, right? I just want you to focus on the implementation part, how I am traversing diagonally. So over here, I'm traversing diagonally. First, I'm traversing through the main diagonal, then through the second diagonal, then the third, then the fourth, then the fifth, and then at the end, the sixth diagonal, right? I hope you have understood this part, right? A quick confirmation would help. Perfect, perfect. Thank you, Samir. Thank you, Jay. So let me quickly try to implement this part. Okay. If you have any questions, just put it in the chat section so that I can answer from there. Just put it in the chat section so that I can answer from there. What I will do over here is, perfect, Kashish, thank you. So what I will do over here is, I will basically first traverse to the first diagonal. So what we are going to do is, we are not going to forget the part that first we are going to traverse to the first diagonal. Then we are going to go through the second diagonal, right? Okay, perfect, 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 perfect. So first diagonal. So we can answer the first diagonal pretty quickly. right? So let me quickly go for I equal to 0. I is less than dp dot length. So I'll quickly make these changes. We don't have to do anything over here. I'll quickly go and I'll write dp of I would be equal to 1, right? It's pretty simple. I don't have to do anything over here, right? I hope you have understood this part. That's the base case part. Now let's talk about other things. So first, to begin with, my length would be equal to 2. So I'm taking a variable len equal to 2, right? So 2, then 3, then 4, then 5, then 6, right? So my variable len would start with 2. Then my len would be less than and equal to s dot length. The length of the substring that I'm using over here, it's equal to this. The string that I'm using over here is A, B, D, B, C, A. The substring that I'm using over here, the string that I'm using over here is A, B, D, B, C, A. And the length is 6. So I would start from 2 and I would go up to 6, right? That's the part that I wanted to focus on, right? And at the end, what I'll do is I'll do length plus plus, right? Now let's try to solve each diagonal. So first, let's try to solve the diagonal with the value 2, right? I have to come up with a generic solution. So what I'll do over here is, I would say the starting index is I, and the value of the starting index to begin with would be equal to 0, and the value of j would be equal to len minus 1, as we have just discussed, right? Then what I'm going to do is I'm going to traverse in an inner loop, right? Just to traverse through all these 5 elements, just to traverse through all the blocks over here, right? So I'm going to do, if I'm going to traverse until j is less than s dot length, right? I'm going to traverse this until j is less than s dot length. You have to notice this part. J is incrementing till it is less than 6. J is incrementing till it's less than 6. 6 is s dot length. Length of the string is 6, right? So this is something that I wanted to solve, right? Then I'll increment the value of j, right? I should not just increment the value of j, I should increment the value of I also. To move from one block to the next block, I should increment the value of ij, right? Both, right? From 0, 1, the next is 1, 2. From 1 to the next is 2, 3, right? So I should increment both I and j. Now let's try to solve dp of ij, right? Now let's try to solve dp of ij. So what I'm going to write over here is, if s dot char at I, if it is double equal to s dot char at j, if both of these values are same, then I'm again going to ask one thing, that if dp of I plus 1, j plus 1, j minus 1, if this value is double equal to j minus I minus 1, if this value is equal to this, then my dp of ij would be equal to, it would be equal to, what it would be equal to? It would be equal to whatever is stored at dp of I plus 1, j minus 1 plus 2, right? This would be equal to this, right? So this is the value of this, right? Else it would be equal to, else my value of dp and ij, else the value would be equal to maximum of the value stored at dp of I plus 1 comma j and dp of I comma j minus 1, right? So dp of I j would be equal to math dot max of the value stored at dp of I plus 1 comma j minus 1 and dp of I comma j minus 1, right? This is pretty simple, right? This is pretty simple, right? And after that, after doing this part, my answer would be dp of 0 comma s dot length minus 1. My answer would be dp of s dot length minus 1. So this is the complete code that we had to write. This is the complete code that we had to write. Let me quickly have some thumbs up if you have understood this code or not. right? So this was the code that I wanted to write, right? Perfect, 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 perfect. So if you have understood this part, just let me know in the chat section. Just let me know. Just give a few thumbs up. This is the diagonal traversal that we have done, right? Another thing that we can do over here is uh, we can solve for I equal to 2 as well. We can solve for I equal to 2 as well. We can make I equal to 2 also as our base case. So what we can do is in I equal to 2, what is the what is the you can say what is the uh, see what is the status at I equal at the length equal to 2. So at length equal to 2, one thing that you have to focus over here is at length equal to 2, I and j are I is double equal to, you can say I is double equal to j minus 1, or you can write it like this, that I plus 1 is equal to j, right? So these are the two values that I can say. So rather than starting from I equal to 2, what you can do is you can start from 3 and you can evaluate I equal to 2 separately, right? You can solve for the second diagonal as well. So solve for the second diagonal as well and quickly write this value. So you can say I equal to 0 and I is less than dp dot length, right? If you want to traverse on all the blocks of length equal to 2, so what you can do is you can quickly say dp of I and dp of I plus 1. You would be going through each and every block uh, uh, on each and every block of length 2, right? And as Samir has rightly mentioned, over here what I'll do is I'll ask that if the character at I is double equal to character at j or character at I plus 1. So if s dot char at I, the answer to this is very simple. If s dot char at I is equal to s dot char at I plus 1, if then the value of dp of I plus 1, this would become equal to 2, right? Otherwise, the answer would be equal to 1. Because as I talked about, you can take any substring in this world, the longest palindromic substring, the least, the minimum value would be equal to 1, right? Now we can quickly run this part. So if we can quickly run this part, so let me quickly run it for A, B, D, B, C, A, and let me see if I get the correct answer or not. The answer that I get is basically, I get string out of bound exception. So why I'm getting a string out of bound exception? Okay, okay. I'm going beyond the bounds. I'm going beyond the bounds. Okay. Okay, let me quickly write 1 over here and let me quickly write 1 over here. Where exactly I'm going beyond the bounds. So it is saying that I'm going beyond the bounds, and that's why this part is saying that at line 48, okay, line 48 is this, line 26 it is saying. At this part, I'm going beyond the bounds. Okay, 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 okay. Exactly correct. I understood this part. So I don't have to increase the size of my DP array. I just have to make sure that this line is correct, right? So what I have to do over here is I have to go up to DP of length minus 1, right? So let me quickly explain you why I've got a runtime error. So you can see over here, I'm traversing on the values of I. So values of I are 0, 1, 2, 3, 4. Earlier, I was traversing on 0, 1, 2, 3, 4, 5, right? As I get to 5, I would be checking two values, 5 and 6. 5 is out of bound. 5 is beyond the bounds of the array. That's why I'm getting an error over there. So what I'm going to do over here is 0, 1, 2, 3, 4. I would stop at 4. So that's why what I've done over here is I've written I is less than dp dot length minus 1. We have to respect this part. So for length equal to 2, I have to stop at that place. So now if I do, it will show me the value as 0. Why it is showing the value equal to 0? That is something which is not understandable. Okay, Perfect, perfect, perfect. So now let's try to find the error in this code. What exactly is the error in this code? Where exactly we have done the mistake? Okay. If somebody can help me find the error, then it would be really great. What exactly is the error? Okay, I found the error. So this should be I plus 1j and it should be I comma j minus 1. This is the error that I was making over here. Okay, got it. A, B, D, B, C, A. Now let me see what would be the answer. Still the answer is equivalent to 0. Why is it this way? If dp of I plus 1 j minus 1, if is equal to j minus 1 minus 1. Okay, if this is equivalent to this, then I should write dp of ij equivalent to dp of I plus 1 j minus 1 plus 2. Mayank, where exactly I'm doing this mistake? You have pointed out some mistake. Can you tell me the line also? Where exactly I've made this mistake? So this is start plus 1 comma end, and this is start comma end minus 1. Right? Perfect. Perfect. If the characters at I and j are equal, then what I should do is I should check whether dp of I plus 1 and j minus 1, the length, if it's equal to j minus I minus 1. Right? Mayank has pointed some mistake, but I'm not able to understand that part. Right? If both the characters are equal, then I would look to this part. The characters are equal, and if this part, if dp of I plus 1 j minus 1 is double equal to j minus I minus 1, I think this is perfect. I think the diagonal traversal is perfect. Any suggestions, people? Because I'm not able to find the error over here. Okay. Okay. Where exactly have we made the mistake? Let me quickly try to print the whole DP array now, and probably that will help me. Okay, let me quickly. Whenever you are in a fix like this, what you should do is you should quickly print your DP array, and it would help you, right? And you will be able to understand where exactly it's not putting the right answers. Okay. I was hoping that one of you would point out the mistake if you have understood it correctly. Okay. Then let me quickly print it. This will be dp of I, j, and let me put a space over here. And then let me, what I should do is I should quickly print a new line over here. Perfect. And then what I should do over here is, let me quickly print this part for A, B, D, B, C, A. Let me see what would be the answer. So everything is going correct. It's just the last part for which I'm not able to find the answer, right? Why I'm not able to find the answer for the last part? That is the part that I'm not able to understand. Why only the last part is equal to 0? So I'm making a mistake somewhere, somewhere over here. I would be equal to 0. Right, right. Perfect, perfect, perfect. So let me quickly see how exactly and where exactly I'm making this mistake. So let me quickly debug this part. Okay. So there is a debug window attached to the Eclipse, which I can use over here. So it will hardly take 4 to 5 minutes. Now let me switch to that part, and I hope you would be able to see everything. So let me quickly move. Okay. Okay. So these are the values that I can see over here. I know for a length equal to 3, there is no problem. For length equal to 4 also, there is no problem. For length equal to 5 also, there is no problem. It is exactly and accurately forming it. I have to check for length equal to 6. That is the place where I'm not able to form the values, right? Okay. Now my length is equal to 6. I go inside, my I would be equal to 0 and my j would be equal to 5, and it's still less than s dot length, right? So it will go inside and it will ask whether the two values are equal. So yes, the two values are equal. Then it will go inside. It will go inside and the inside value was not executed. So inside value was not executed. So it quickly gave up, right? It quickly gave up and it relinquished the part. It relinquished this part. Okay. So what I should do is I should write the else part over here as well. That even if this condition is not true, even if this condition is not true, or exactly, or what I should do is I should not write the else part over here. What I should do is I should ask a simple thing. I should ask a simple thing. I should ask a simple thing that this condition is true. If this condition is true, I should ask whether this value is equivalent or not. If this value is equivalent, then this would be the answer. Else what we can say is we can take this else from here and we can put the else over here, right? If even if this condition is not true, then we'll check for this part. Even if the first two characters are equal, राइट इस पार्ट को थोड़ा सा अच्छे से समझने की कोशिश करो. आई हैव मेड अ मिस्टेक ओवर हियर, सो आई वांट टू क्विकली मेक यू अंडरस्टैंड दिस पार्ट. Right, before explaining this, I want to quickly see whether I have find the right answer now or not. Right, so now I have found the right answer. It is equal to 3. Now let me quickly see for another test case as well. A, B, C, C, B, and let me quickly write D. So the answer is 4. This is exactly coming correct now. Okay. So now let me explain what exactly was the problem that I was doing. So मैंने यहाँ पे if के बाद else नहीं लिखा था, as Sameer has rightly mentioned. So यहाँ पे हमें क्या देखना था? For A, B, D, B, C, A, इसके लिए right answer नहीं आ रहा था. Right? हमारा 0,5 के लिए right answer नहीं आ रहा था. Right? और जो right answer नहीं आ रहा था वो इसलिए नहीं आ रहा था क्योंकि वो यहाँ पे if वाले part में जाता था. And the first condition was accurately right. उसके बाद वो ये वाली कंडीशन चेक करता था क्या इनर सबस्ट्रिंग का जो लेंथ है क्या वो 4 के बराबर है. इनर सबस्ट्रिंग का लेंथ 4 के बराबर नहीं है, सो वो डायरेक्टली बाहर आ जाता था. राइट, इनर सबस्ट्रिंग का वैल्यू 4 के बराबर नहीं है तो भी हमें ये तो पूछना ही चाहिए ना कि इस पार्ट में और इस पार्ट में मैक्सिमम कौन है. राइट, वी शुड आस्क दैट व्हाट इज द मैक्सिमम इन दिस पार्ट एंड व्हाट इज द मैक्सिमम इन दिस पार्ट. हमें ये बात तो पूछनी चाहिए. So even if the inner part is not equivalent, length of the inner substring is not equivalent to the length of the longest palindromic substring for it, हमें ये वाला पार्ट तो करना ही करना पड़ेगा. राइट, तो इसलिए मैंने वो वाला पार्ट else में लिख दिया. राइट, इसलिए मैंने वो वाला पार्ट else में लिख दिया. I hope you were able to understand this part. ये वाला पार्ट आई होप आपको समझ में आ गया है. राइट, एक क्विक कंफर्मेशन दे दो इफ यू हैव अंडरस्टूड दिस पार्ट और नॉट. राइट, सो आई एम वेटिंग फॉर योर कंफर्मेशन. इफ यू कैन क्विकली राइट, गिव मी अ थम्स अप so that I can understand that you have understood the mistake that I was making. Right, quickly if you can do that, it would be really great. Then I would move to the second question of our contest, which is exactly similar to the question that we have just solved. Right? I'm waiting for a quick confirmation. If you can give that quick confirmation, it would be really great. Okay, okay, okay. So Jay Shukla is saying yes, but Sarthak has a question. So Sarthak, what is the else part doing? Else part will only work for the place where this part, where the first two characters are equal, right? So let me take two examples, J, just to make you explain. Okay, so let's suppose A, B, D, B, C, A is given. So this part will work only where the first two characters are equal. So if the first two characters are equal, I'll ask two things. I'll ask whether the inside substring, the length of the inside substring is equal to the length of the longest substring of this substring. So the length of the longest substring is 3, but the length of this is 4. So I cannot apply this part. But still, I should ask this question to it that A, B, D, B, C में से और B, D, B, C, A में से बताओ मैक्सिमम कौन है. I should ask this question. इससे पहले मैं ये वाला पार्ट स्किप कर रहा था. ये वाला पार्ट तो दोनों के लिए आएगा ना, चाहे ये वाले कैरेक्टर्स बराबर हो चाहे ना हो, राइट? So I hope you have answered your question. Let me quickly answer Kashish's question as well. So Kashish, आप मेरे से पूछ रहे हो कि सेकंड डायगोनल्स मैं आपको एक्सप्लेन कर दूं. ठीक है, मैं आपको सेकंड डायगोनल एक्सप्लेन करता हूं. जस्ट गिव मी अ सेकंड. ओके, परफेक्ट. सो सेकंड डायगोनल में हमें क्या करना है? सेकंड डायगोनल के अंदर जब लेंथ इक्वल टू 2 था, सो मेरा आई और जे का वैल्यू एक बार ध्यान से देखो आप. स्टार्टिंग का वैल्यू 0 1 था, सेकंड वैल्यू मेरा 1 2 था, और फिर मेरा 2 3 था, फिर मेरा 3 4 था, और आखिरी में मेरा 4 5 था, राइट? और तो कुछ नहीं था, यही वैल्यूज था. मैंने यहां पर यही करने का कोशिश किया है, राइट? आई इक्वल टू 0, आई इज लेस देन डीपी डॉट लेंथ माइनस 1. आई इक्वल टू 0, डीपी डॉट लेंथ इज 6, डीपी डॉट लेंथ माइनस 1 is 5, आई इज लेस देन 5, यानी आई विल गो फ्रॉम 0 to 4. How I have compared two values? I have compared two values by taking I and I plus 1. इन दोनों में I और J में फर्क यही है, I और I plus 1. अब अगर मेरे को इसका वैल्यू पता करना है, अगर ये दोनों कैरेक्टर्स बराबर है, then the length of the longest palindromic substring would be equal to 2. And if these two values are not equal, then the length of the longest palindromic substring would be equal to 1. It would be equivalent to 1, right? That's what I have done for the diagonal, right? I hope you have understood this part, Kashish, right? Perfect. I would like to move to the second part of the question. So in this part of the question, what we have to do is we have to find the count of the palindromic substrings. How many palindromic substrings do we have? I have to find the count of that. ये जो second question है हमारे पास, इसमें palindromic substrings का count करना है, right? Is my sound not coming, people? Just let me know if my audio is not audible. Okay. Let me quickly check then. So is now the sound coming? Just let me know if the sound is coming now. Okay. First, if you can please let me know if I'm audible or not, then it would be really great. It's audible now. Okay, perfect. So what I was talking about over here is that the next question that we have over here is the count of palindromic substrings, right? So I just have to find the count of palindromic substrings. So for that, I need to see this part over here, right? So this is the this is something, this block that you have created. This would be very relevant for you. So try to solve this question. Rohan, before moving to the next question, I want to make sure that you all understand this part. So try to solve this question, palindromic substrings, using the information that we have already found. So you can create this matrix, and after creating this matrix, you can solve this question using a small trick, right? I just want to know that small trick from you. I want to know that small trick from you all, right? Just let me know about that small question, about this small trick, right? Just let me know about that small trick, right? इस क्वेश्चन को एक बार सॉल्व करने की कोशिश करो। ठीक है, ठीक है, आई अंडरस्टैंड दैट आई एम ऑडिबल। इस क्वेश्चन को एक बार सॉल्व करने की कोशिश करो एंड जस्ट लेट मी नो इफ दिस पार्ट इज क्लियर टू यू। अगर आप इस प्रॉब्लम को इस पार्ट से सॉल्व कर सकते हो। आई वांट टू काउंट पैलिंड्रोमिक सबस्ट्रिंग्स। सो ये जो डीपी एरे हमने बनाया है, क्या इससे आप पैलिंड्रोमिक सबस्ट्रिंग्स को काउंट कर सकते हो क्या? ये बताओ कैसे पैलिंड्रोमिक सबस्ट्रिंग्स को काउंट करेंगे? आई थिंक यू शुड बी एबल टू आंसर दिस क्वेश्चन, राइट? I would not be going to any other question. So I just want you to focus on this question that I have over here for you. So from the 2D array that I have created over here, I want you all to try to find the count of palindromic substrings. If somebody can give me the answer, it's well and good. I'm giving you 2 more minutes. Try to find the answer to this question. Otherwise, I'll explain the solution. Just let me know. Just let me know the solution. I think we have to find the count of palindromic substrings. We have just solved the longest palindromic substring. I have to do a small tweak in this question. I have to do a small calculation. I have to just do a small calculation over here, and then I would be able to solve this question. Then I would be able to solve this question. कोई बता सकता है क्या किस तरीके से हम इसको सॉल्व करेंगे? I want more and more people to achieve 120 out of 120. ये दोनों क्वेश्चन मैं चाहता हूं सभी लोग सॉल्व कर लें, right? We have only one person who have achieved 120 out of 120. I want everybody to solve this question, right? Anybody? Any approaches? सिर्फ ये 2D एरे को देख के सॉल्व करना है। चलो मैं आंसर बता देता हूं। Shall I tell the answer? Shall I tell the answer? हाँ समीर, थोड़ा सा और इलैबोरेट कर दो। लेंथ की जगह काउंट मेंटेन करके हो सकता है। पूरे के पूरे आंसर में चेंज करने की जरूरत नहीं है। आई एम सेइंग एक बार अगर आपका ये आ जाता है, वंस यू आर एबल टू रीच अप टू दिस लेवल, इसमें आपको कुछ काउंट करना है। हाउ डू यू से अ पर्टिकुलर सबस्ट्रिंग इज अ पैलिंड्रोम? इसमें कुछ काउंट करना है। जैसे कशिश कह रही है कि टेक अ काउंट वेरिएबल। कशिश, यू आर ऑन द राइट ट्रैक, यू हैव टू काउंट समथिंग। व्हाट एग्जैक्टली डू आई हैव टू काउंट? सो I comma j, I comma j. If I talk about it is traversing over all the substrings over here, how do I say that I comma j is a palindrome? How do I say that dp of ij denotes a substring which starts at I and which ends at j? How do I say that the substring which starts at I and ends at j is a palindrome? How do I say that? बस इतना simple सा question है. If somebody can answer that, I want you to answer that. I would wait for another minute and then I would disclose the answer. इस क्वेश्चन को आंसर करने की कोशिश करो। डीपी ऑफ आई जे को आप पैलिंड्रोम, उससे आपको पैलिंड्रोम कैसे पता चल सकता है? Okay, I think you would be able to answer this question. Perfect, perfect, perfect. Finally, we have the answer.
It would be j minus I plus 1. सो समीर ने बताया है कि जिस भी सेल के ऊपर वैल्यू j माइनस आई माइनस 1 होगा, राइट? सॉरी सॉरी सॉरी, परफेक्ट परफेक्ट, समीर एकदम सही बोल रहा है। जिस भी सेल पर वैल्यू i प्लस जे प्लस 1 होगा, sorry, again I'm sorry. So like for example, if we have A, B, D, B, C, A, whether it's palindrome or not, it would be stored at the value would be stored at 0,5. What it is stored at 0,5? It's stored 3. So ये palindrome कब होता? अगर इसके longest palindromic substring की value अगर 6 होती, अगर इसके longest palindromic substring की value 6 होती, तो ये मेरा पूरा का पूरा सबस्ट्रिंग पैलिंड्रोम होता। सो मैं इसको निकालने के लिए क्या बोलूंगा? j माइनस आई प्लस 1, ये मेरा फॉर्मूला होगा। अगर dp ऑफ आई जे की वैल्यू j माइनस आई प्लस 1 होगी, तो मैं ये बोल सकता हूं कि वो सेल में जो सबस्ट्रिंग रखा हुआ है वो पैलिंड्रोम है। जिस भी सेल के अंदर dp ऑफ आई जे की वैल्यू j माइनस आई प्लस 1 होगी, वो मेरा क्या होगा? पैलिंड्रोम होगा, राइट? 0 0 पे जो वैल्यू होगी 0 0 1 1 2 2 3 3 4 4 5 5, ये सब पैलिंड्रोम होंगे। क्यों होंगे? इन सब पे वैल्यू कितनी स्टोर्ड है? इस पे 1 स्टोर्ड है। और यहाँ पे j माइनस आई प्लस 1 का फॉर्मूला अप्लाई करके देखो, 0 माइनस 0 प्लस 1 इट इज ऑल्सो इक्वल टू 1, सेम आ रहा है। 1 माइनस 1 प्लस 1 1 आ रहा है। 2 माइनस 2 प्लस 1 1 आ रहा है। सो आप देख सकते हो कि 1 लेंथ के जितने भी हैं ये सब पैलिंड्रोम्स हैं। मेरे को काउंट करने हैं, काउंट ऑफ पैलिंड्रोमिक सबस्ट्रिंग्स। सो ऑल दो सेल्स व्हिच हैव दिस वैल्यू वुड बी माय आंसर। सो ऑल दो सेल्स जिसके अंदर j माइनस आई प्लस 1 इज इक्वल टू dp ऑफ ij, that would be my answer. So I hope you have understood this part. So I hope you have understood this part. काउंट ऑफ पैलिंड्रोमिक सबस्ट्रिंग्स की अगर बात करें तो बहुत ही सिंपल है काउंट ऑफ पैलिंड्रोमिक सबस्ट्रिंग्स। काउंट ऑफ पैलिंड्रोमिक सबस्ट्रिंग्स के लिए मुझे सिर्फ और सिर्फ j माइनस आई प्लस 1 को चेक करना है वेदर इट इज इक्वल टू dp ऑफ ij, right? If it is equal to dp of ij, I would say that this is something which is equal. So this is something, अगर ऐसा मिलता है तो I'll do count plus plus, और फिर लूप से बाहर निकल के I would return the value of count. The value of count would be the count of palindromic substrings. Just let me know in the chat section if you have understood this part or not. कुछ part अगर इसमें समझ में नहीं आया तो please पूछ लो. I have discussed the solution of all the 4 questions. The 4 questions that I had targeted, I have explained, I have discussed all the 4 questions. Right? I hope you have understood those 4 questions. Just let me know in the chat section if you have understood those 4 questions. किसी भी क्वेश्चन में कोई डाउट है तो प्लीज पूछ लो। स्पेसिफिकली लास्ट क्वेश्चन में कोई डाउट है तो प्लीज पूछ लो। इफ यू डोंट हैव एनी डाउट्स, अ क्विक थम्स अप वुड बी रियली ग्रेट। So just a quick thumbs up would be commendable. Okay. Okay. So okay, thank you Samir, thank you. So what we have to do is, I just want to summarize now. So this is the summary, right? We have to work on recursion, then we have to see where repetitive calls are being made, then we have to memoize code with storage array, then we have to create the alignment, we have to create a mapping between the recursive call and a cell of the storage array, right? And then at the end we have to solve the entire question with the help of the storage array. This is how this entire question was to be solved. This is entire dynamic programming is based, right? And I would again reiterate, try to solve this question. Make sure that you are able to get 120 out of 120 over here, because we have solved each and every question, like Harpreet, Rahul, Ankit, and all the people over here, Kashish, Samir, Vinod, Vansh, all the people, try to get 120 out of 120. Submit your solutions over here, right? Ashok, you can put your query. Let me know what exactly is the thing that is troubling you. Put your query. Apart from that, I want to bring your focus on the webinar that I took on June 11, right? This is the webinar that I took on June 11th June. And what we have to do over here is, over here you can see that there are This was around 2 hours webinar that I had taken, and I had elaborately explained. I have written notes over here as well. So the notes are on Fibonacci pattern, and the notes are on the 0 1 knapsack pattern. As you can see, in the patterns, I've divided the dynamic programming in form of patterns, right? You must have seen that in Fibonacci pattern, staircase was similar questions to minimum jumps to reach the end. Similarly, longest palindromic substring was similar to count of palindromic substrings, right? Similarly, these are 6 patterns that I had shown over here. So what I want to focus on over here is that if you want to really learn dynamic programming properly, so what you should do is you should see this webinar as well. This webinar that we have just delivered would be basically in continuation to the webinar that I have given on 11 June, right? So I would recommend all of you to go through this webinar. Just type Coding Ninjas DP and you would be able to get this webinar on dynamic programming, right? I hope I was able to resolve all your queries. Thank you people for listening, and thank you for being so patient, right? Okay, that was all that I wanted to talk about on DP, right? Thank you. Okay, bye bye. Good night. Thank you for patiently listening.